awakened enough to listen to the interesting courses in the morning and then in the afternoon. So the first one is a very interesting one. It will be presented by Hristo Tanev, who is a project officer and researcher at the Joint Research Center of the European Commission. So his interests are basically in the computational linguistics, but also natural language processing, and it includes technologies and resources. More specifically, he works on event extraction. This is a very modern and very important line of research these days because it's related to false news and um, maybe forensic linguistics and so on. Also, text classification, question answering, social media mining, lexical learning, and everything is put in a multilingual context. So, what to say about more about Hristo? I have known him for a long time. I would mention that he graduated from the University of Lviv, but then he worked in ITC in Trento, Italy. And currently he works in ISPRA, Italy, in the Joint Research Center of the European Commission. Another important thing is that he's one of the founders of the Special Interest Group of Slavic Language Processing at Association of Computational Linguistics. And here I would like to say that we had some work together a long time ago about question answering for Bulgarian. And he, together with a colleague of ours, they developed a system that was called Bulka. Bulka means not only Bulgarian question answering, but also in Bulgarian it means bright. So it's very nice one. And I hope that at some point we can do more about it, right? Hristo, okay. So the floor is yours and please enjoy his course.
Thank you. Thank you for this. Thank you for this very nice presentation. I have flattened. As Petya says, I'm working for the European Commission. My primary area of research is sociopolitical event extraction. I've been teaching assistant in the Plovdiv University, and my recent work was concentrated entirely on working for the European Commission and for the Joint Research Center, and especially in the area of sociopolitical event extraction. So basically, we have built a system for extracting sociopolitical events, news about armed conflicts, about protests, about various types of socio-political happenings in the world. And the system was developed, it was multilingual, it works in 8 languages, and it has been used in the African Union, then it has been used for in various intelligence services, even across European countries. And currently, it is in use in the European Commission in some directorates, and this event extraction system was the reason that I wanted to share with you a little bit of my experience in event extraction. So, in order that everything works well, I would like that I send you and I will put these slides online. But if you're interested, please write me this email, and then I'll send you the slides, because the function of this tutorial is to give an overview, and this overview basically means that I have put together various links to resources and to data which we can use to train your systems. So in order to have those links, the best thing is to have the slides, and you can write to me and I'll send you the slides. That's the best. So this was that our online audiences looks at the slides because they should be shared. That's why I think this interruption. So I wanted to start with a brief overview of the field. What is event extraction and why one should be interested in it? Um, so basically, in order to make you, the purpose of this tutorial is to make you aware of the most important aspects of the event extraction in the sociopolitical domain, to give overview of the event extraction technology, to provide information about the event extraction data flow, to look into the algorithms and models used in an event extraction system, and to present some real-world event extraction systems for the sociopolitical domain. Then I'd like to present three sources of sociopolitical events data for training event detection models and systems. First, what is an event? The American philosopher Donald Davidson says that events are special temporal things, so concrete particulars with a location and in space and time. He says this in his work on the logical structure of sentences and actions. It's called The Logical Form of Action Sentences in 1967. And later work on events and their linguistic representation is done by Leonard Talmy in his work towards cognitive semantics. He also explores the linguistic aspects of events. What is important about events? They're central for the news. The news streams are based on reflecting events. So event extraction technology is the most important technology in information extraction if you want to process the news, because event extraction detects events and each news reflects an event. The news do not reflect facts about people, they do not reflect scientific facts, the news reflect events. So the events, under them, there are named entities, there is time, there locations, there are sentiments. So all these information extraction technologies somehow are under the event extraction. The event extraction is the most important technology if you want to process news streams. And so events are central for the journalism and the media, and in fact news articles and news streams are reporting on events. Social media posts which reflect news and also reflect events of various importance and nature. So event extraction is important because the news nowadays are extremely large as a volume, extremely large as a variety of content. So everyone who wants to process the news should have an idea of what the event extraction technology is, because this technology is about processing news. So event extraction is an NLP task which was born out of the need of political business organizations to monitor news and social media, as I said, and the purpose of event extraction is to extract highly focused information about specific type of events. And they're described in the news articles, these events in the social media communications. Events are reflected in Facebook, in Twitter, in LinkedIn even, also on Instagram, Telegram. Recently we have collected news from Telegram about the Russian-Ukrainian war. All those social media sources are additional source of news together with the mainstream news. So what is event extraction? Formally, event extraction answers to the 5 why, 1H question: who, when, where, what, why, and how. So this news, at least 11 Palestinians have been killed by the Israeli forces in the north of the occupied West Bank. Palestinian health officials said 6 people died in drone strike, 9 clashes in Jenin, and 5 were reported killed in airstrikes in Al-Farah, a refugee camp in Jordan Valley. Israel security forces say it is carrying out a counter-terrorism operation. So who's doing that? This is Israeli forces. They started the action, they did the event. The Israeli forces initiated, they triggered the event. It happened on 28th of August 2024, where there are 2 occasions where the Israeli forces hit Palestinians near Jenin and in the Jordan Valley. And what happened? The outcome is 11 Palestinians are killed. There is no further specification how this happened. They used airstrikes or they killed them by light weapons. That's why we said what is 11 Palestinians killed. Otherwise, this could also be about the way this happened. Actually, the way it happens is in the hard question: drone strike, airstrike, and armed clashes. So this is the way. So the what is the outcome of the action. So it is 11 Palestinians killed. Of course, how is connected to what? Because you cannot just say what happened without saying how it happened. But if we want to go to bring our analysis to the end, we can say that what is 11 Palestinians killed and how is that the drone strike, airstrike, and clashes. And the way is the reason. The reasons are deep, but Israeli says that in inverted commas counter-terrorism operation because the journalists do not agree completely with the Israeli statement. He just cites that that's a counter-terrorism operation, and that's the reason which is mentioned. In reality, what is not there. So you have the idea, basically, these slides already gave the idea what is event extraction. We search what happened, how many people are killed, who is killed, who triggered the event that's the actor or the perpetrator, how it was done, with what weapons and what means, what tools, and why the motivation, which is more difficult to get to capture from the text, of course. So the brief history of event extraction. Brief history, this reminds me of Stephen Hawking's brief history of time. This is brief history of event extraction. It is 35 years already, this technology, because message understanding conferences were initiated in 1987 and they were financed by the DAFCO, by the Defense Advanced Research Project Agency, which already means that the military and the security people are the first who are interested and the first who introduced this technology. So this technology is primarily client at the security people and the politicians. And the inception of this technology was it was in the context of the military. And the DARPA did this competition. The first competition was about open event extraction, which means that there is no fixed template. So the systems were supposed to extract as much as possible participants, names, interactions, types of events, event triggers. But from 1999, they introduced the so-called event scenario template, and this event scenario template says exactly that the event should be, the system should extract the event type, the event victims, the event perpetrators, the event location, and possibly other information like weapons used and maybe also the motivation. So this is the so-called closed event extraction. We have a well-defined event template, and the system must fill this template within the specific slots. So we have a predefined slots. This is closed event extraction, closed domain event extraction. MUC conference introduced the competition name entity recognition and name entity reference, and they continued until 1997. And then they were followed by the ACE, by the Automatic Context Extraction, which is a research program for developing advanced information extraction technologies. including event extraction, and it was organized by the NIST, the National Institute of Standards of the United States, and continued until 2008, succeeding MWC, and then it was followed by the Text Analysis Conference. The ACE provides a annotated event corpus distributed by the European Language Research Association. So if you want to have access to their event corpus, you must be a member of the ELRA or pay more than 1,000 euro to get this corpus, or you should know someone who has this corpus and ask him how to give it to you for research purposes. Of course, it's okay. Or doing more is not okay. You should buy it. And the text analysis conference stopped the development of the event extraction technology, and then it continued into question answering, sentiment analysis, and other technologies, the so-called TAC tag. And then in 2019, a group of people from the Istanbul University, and I joined to them later, they decided to organize a workshop on challenges in applications in automatic extraction of sociopolitical events from text case. So this workshop is the workshop for event extraction, and we're trying to organize this every year, paired with the most prestigious conferences like ACL, like MNLP, RANLP. And if you're interested in event extraction, you should come to our workshop, and also you should participate in the shared tasks. And we have shared tasks from event extraction, geolocation, and the next year we don't know where we'll be able to be at ACL, but we don't know. So we feature various shared tasks on geolocation, protests and battles, shared tasks on detecting social political events on pre-level document sentences in token level. We have shared tasks on hate speech detection related to events. And next edition will be in 2025 if the workshop is successful to be accepted. I want to say some more about it because this workshop is really the only place now focused on event extraction. The link to the last edition is this one. It is the Istanbul University, and we have a Higgs channel, and we provide corpus from data for event extraction. So this corpus is available in general for the people who participate in the shared tasks. But if you write to me, I will try to give you this corpus, since it is good corpus with various social political events, battles, protests, and unrests, and collected mostly from China and India. So it is geographically specific. So what is the template of the social political event extraction? Usually, event description can be put in the following template. There is event trigger, for example, fighting for pay. There is the type, protests with police violence, talking about this example. The time is 15 November, location is Bangladesh, actors are garment workers, they started the protest, and the victims are not mentioned. The motivation is pay, and exploited instruments are also not mentioned, but in general they are here working with weapons, cocktail. And also it's important impact on the population, the infrastructure, and the economy, and they can be shown and formalized with different slots. Like, for example, there could be people who are refugees, internally displaced refugees, for example, destroyed buildings, destroyed homes, financial losses, closed roads, interrupted services inside the cities. So those things can be formalized as slots in the event template. Certainly, the event template is decided by your system, by the system which you're building. So it is not predefined. There is no one template for all the systems, and it is specific for each system. So continuing about the event template, it can be, each event can have its own event template, pretty much like in object-oriented programming. Each object class has its own fields. And for example, a kidnapping event has its own kidnapping template. And apart from type and location and perpetrators, they will have the kidnapped people and then the dead and injured people during the kidnapping. But on the other hand, if we talk about battle, then you will have two sides, attacker and attacked. So two actors, and one is the active one, the other is the passive one. And the number of dead and injured for a battle, for example, is more important. And for the kidnapping, for example, security-related event, it is more important the identities of the kidnapping of the kidnappers and the identities of the people who died, because they're less in number. So usually the event extraction systems, the socio-political event extraction systems, they're covering specific types of events. So why certain events are being detected by the event extraction system, why others not? Usually it is defined by the impact which the event has on the society, and if the event is important for the people who are writing the news, if it is important, if the event has certain importance for the government and for the big mass of people, for the society. So users and developers of state-of-the-art event extraction system are concerned nearly exclusively with two specific group of events. These two group of events are crisis events and business events. So the crisis events social-political events and also disasters, disease outbreaks, and also incidents with large-scale incidents, man-made incidents. And on the other hand, the business events, they do not have direct impact on the society, like for example, the change of CEO of a company, but they're important because the company directly influences on the economy, the business influences on the economy, and although these business events do not have direct impact on the society, in principle they're relevant for the people who do business and companies who do business intelligence. And in the long term, the business event can also have impact on the society, on the economy of a country. So the crisis events are social-political events are subtype of the crisis events. So I'll talk more about them. So there are two types: security-related events and like armed conflicts, protests, and crimes. Big crimes are social-political. Small crimes are just crisis events. And then we have also disasters, humanitarian crises, disease outbreaks, as well as financial economical crisis. So these are the important type of crisis events. So business events are usually company mergers, change of the stock price, there's new CEO appointed, etc. Some event extraction system and databases are concerned with diplomatic events also, meetings, summits, treaties, which are considered related to the security. They are social-political events which are not crisis events. So social-political and crisis events have an intersection point in the armed conflict, in protests, but social-political events can also include political events like diplomatic events, and the crisis events can include events which are not social-political but have impact on the society, like the massive disasters, for example. So some event extraction system basically they detect exclusively crisis events, and so they are oriented towards disasters and battles and armed conflicts, and some are concerned exclusively with health disasters, with disease outbreaks, for example. There is a system created in New York University pools, which is detecting disease outbreaks. And we in the Georgia Center also have a medical event extraction, part of the medical information system, which detects disease outbreaks. This system is active, and if someone is interested in health-related event extraction, he can use our medical event extraction system. Certain event types reported in news remain mostly out of the focus of the event extraction system, and these are sport competitions, personal events like weddings, social events, press conferences, and cultural. cultural happenings. This type of events are usually not considered important for the society, so the politicians and the people from the school, they do not invest in monitoring this type of news, they do not invest in monitoring social events, but they invest in monitoring the protests and armed conflicts. So these are the events which are being monitored. So the criterion of technology tech is defined by the immediate impact of the event on the society, and typically crisis event detection systems are capturing news fragments, reporting some damage on people, such as death, injury, etc. Crisis event may only indirectly affect the people by destroying buildings, infrastructure. Business event detection systems, on the other hand, are concerned with business events and benefit mostly business organizations. So, social political event, what is it? So, a social political event is event which this event type it encompasses military interventions, civilian unrest, protest, strike, riots, terrorism, insurgency, political meetings and summits, international treaties, elections, lack of food and water, refugee influx, massive destruction of homes, infrastructure, famine, drug wars, and financial crisis. So this is what the literature says about social political events. And automatic construction of databases for political analysis and early warning is one of the most recent trends in the social-political field, in the field of political analysis. There are more than one, actually, probably 10 big projects for constructing databases of social-political events and disasters in the world. And some of them use automatic systems, automatic event extraction systems. Some manual attack crisis rooms in some big organizations, in international organizations, in security organizations. During times of crisis, the people who are responsible for managing the crisis, they sit in front of big screens, obtain information and maps, including from the news, from event extraction systems, including from satellites, about the development of the situation, of the crisis situation inside the certain region. Usually this is during massive natural disasters. And there are also information systems which trigger alerts about military incidents, protests, riots, large-scale disaster humanitarian crisis. For example, our Europe Media Monitoring System is triggering alerts about important events and sends them through the email and SMS to journalists and people from the European Commission. So these applications require event extraction technology, which backs up them. And also it is important to follow the number of victims of armed conflicts in humanitarian crisis and other social political events. And this is again done with event extraction. So this is a small sample of event extraction extracted by the Joint Research Center Nexus system. So event type is armed conflicts, and the weapons are missiles and drone, and this is about the Philippine urges its Marines to avoid Red Sea and meet Houthi attacks. And since the news mentions the Houthi attacks, that the Houthis are attacking the ships with drones and missiles, then we have captured this as armed conflict, and the weapons is missile and drone. And then we also extract the snippet, and this is the snippet which you see on the screen. So this is another example. This is from the Russian-Ukrainian war, how basically the high precision strikes in Kursk, in Kharkiv. So this was some days ago, and when the news was published was 3 minutes ago, and the system recognizes automatically this airstrike, and it recognizes the weapon, which is a drone, and there is a snippet which is captured by the system. And there is another example. This is about shooting. The police officers killed. The reason is not, the motivation is not clear. That is why the system says it is shooting generic type. And it also finds that the weapons are grenades and the guns and some other weapons. So this is all automatically extracted information, and it appears on our website, and it also enters into database of events automatically extracted. So this was about the national system which we developed, and this is another project developed in United States. It's called Global Incident Event Map by the project Global Database of Events, Language and Tone. So the name of the project is Global Database of Events, Language and Tone, GDELT, so-called GDELT. It is a project, a very significant project. It monitors a huge amount of data, huge amount of news in different languages, and extracts actors, places, time, and the manner. And basically, this project is one of the most interesting projects in event extraction. Automatically extracted events are filled into a database shown on the map, which you see here. So this is another way to visualize and present events to a map. And this one is another system which was developed inside our center. It is now being used in the World Health Organization by a new big project which is called Epidemiology, Epidemic Intelligence from Open Sources, AEOS. So this is based in Switzerland, and then monitoring after COVID, they started to monitor the propagation of the various disease outbreaks, their development. And we managed to capture the place where outbreak and related to the outbreak events happen, and the number of victims. And so this is shown again on a map, and you can click on a point and see the details. So this is from the World Health Organization, this event detection system. This I think you should see then in the slides. There are all the links, and you should test yourself. There are systems which you can directly use and see how they're working. So which are the stakeholders of the event extraction? These are researchers in political science. So there are researchers in political science which use the work of the researchers of natural language processing. So what you do in event extraction is likely to be used by other researchers in political science. So it's interdisciplinary domain. So you do research in one area, it's being used in another area. And there are these security people, policing, military, they're really crazy about this type of system. They want to monitor the news, and there are various systems in the world which monitor the news, and they pay big money to the NLP experts. So if you become good in the future, you're likely to work for the police and military, if you like. And then there are the decision makers in governments and international organizations. These are, let's say, more civilian people who are in power and use the output of our systems in order to monitor the development of conflicts and then decide if they can intervene in some area or not intervene. So this brings clarity and improves the decision-making process in the political and international organizations. This is very important area of application of our technology, of the event extraction technology. So I have seen how the European Commission is using it, how the World Health Organization is using it. So this is something which stimulates me personally to work in this domain. Event extraction is really useful, and information extraction in general is useful for the decision making in political organizations. Now we're passing to the serious part, to the more technical part, and this is the data flow. So I'm going to sketch the various stages of event extraction, and then we'll go through each stage and we'll talk very briefly about the models and the resources which are being used. Very briefly, because there are many technologies underlying event extraction. So it starts with text stream of news and stream of social media messages, which can be clusters of news, clusters of social media messages. And then we have pre-processing. The pre-processing is done through name entity recognition, through parsing, syntactic parsing, dictionary matching, And then this is passed to the next stage, which is about argument extraction. And here the arguments, so the participants in the events, the locations, the temporal expressions, they're being extracted inside this box, inside this stage. So victims, perpetrators, weapons, temporal expressions, and basically, this is all information which is not related to each other. So, you know, there are killed people, there are injured people, but which is the event? Maybe there are different events, and one argument belongs to one event, and the other argument belongs to another event. So, one location belongs to one event, and one location to another. So, this is the last stage. But before the last stage, we have the text classification for and it discovers the events and makes event typization. So, for example, the systems may perform event detection on sentence level, and then they classify sentence using text classification techniques, using various techniques. And then it may be done on a basis of text fragments. So some system analyze just the beginning of the news article, so they classify the news article. So some systems may even capture, they do some sort of event aggregation, get the arguments, and then get the snippets which can around these arguments, and then make classification after them. Usually event aggregation is like one of the last stages, so can be before or can be after or before the text classification, before event classification actually. Then the purpose of the event aggregation is to aggregating event templates, so creating, identifying the events out of the arguments and the classified sentences. So you imagine there are various entities, and then they're grouped into events. And this is the last stage, which is called event aggregation. So it aggregates event templates, finds if there are many events in one news article, and also it can link events to previous similar events, performing event co-reference or event causality. And now talking about preprocessing. Preprocessing is the most basic preprocessing is the event recognition. Without event recognition, you cannot have an event detection system. So you have this snippet, for example, that Gardini Donegal have seized 3,000 mapping products, contains suspected illegal cannabinoids, and during the course of the searches, they carried out in this city on 22nd of August. So what is important for every system which wants to analyze the news is the first step is to see which are the name entities, which are the organization, which is Gardai, is the Irish police, is called Gardai. The city, Donegal, then there are two other cities, Bundoran and Donegal town. Then there are financial number, which is 3,000 euro, and this is also important, and the date, the 22nd August. Then we have the dictionary matching, which is also very important. The so-called event triggers, like in this case, Seizure, have ceased, usually are inside resources which are called domain-specific dictionaries. So these dictionaries are built in different ways. Could be automatically, semi-automatically by experts. So in these dictionaries, you have, for example, a phrase like "was killed." This is killing event, have seized, seizure event, kidnap, abduct, kidnapping event. Roughly, very roughly, this is how event dictionary looks like, event trigger dictionary looks like. So this dictionary items are matched inside the text using simple dictionary matching algorithms. Could be also regular expressions rather than fixed strings. And then it is important, but this is considered rather trivial to make sentence splittings. There are various tools for sentence splitting. And because usually events are reported in one, two, or three sentences, so it's important to capture the sentences. And then there is the argument extraction phase, which extracts the participants, extract the time, affected infrastructure. And so this example how from a text we arrive to the template. And so in this case, it is a news about Russian bombardment of the East Ukraine, and then we have event places, the identities of the dead people, how they are identified inside the text. So 6 people, 4 people, the perpetrators, and the effective infrastructure, which is a house. So this is the argument extraction, and this is before the other stages. It's an important stage in event extraction, argument extraction. There is a very important phase which is called event classification. So event classification is about having the text which describes the event, having the snippets which describe the event, and then we classify the text using text classification techniques, and we come out with event types. So we know that this event which is described in these sentences is of a specific type. For example, in this example, the word bombardment can trigger the event type air attack. And this can be done in different ways. Event classification can be based on sentences or bigger multi-sentence text fragments. And it is based, importantly, it's based on taxonomy, on a set of event types. And a very important taxonomy, for example, in the world of sociopolitical domain, is the Camel taxonomy. There are both machine learning based data-driven methods for text classification and keyword-based event classification techniques. So both are in use. And as I said, the last stage is the event aggregation. So from all this information, the event type and event arguments, we build the event template. So in this case, the event template about this news will be air attack. Event place is Donetsk, and that is 6 people. And then during the aggregation, we also parse the number of dead, the number of injured, the number of kidnapped. So there is parsing of the text and extraction of the numbers. So in this case, the number of dead is 6. And it is also important that the systems here should capture ideally 2 events. One event is of type air attack, which happened in Donetsk, and then another type is of unknown event types where Russians are perpetrators and the death of 4 people, and the infrastructure is a house. And the event place is another, is Malivka, is a village in Ukraine. So on this stage, the system should group the arguments, the sentences, and should extract the event templates and should define the number of events. It is also important to know that it is not trivial to identify the different events inside one news article. One news article can report many events. So in this particular case, you can see the news which talk about 58 Palestinians who were killed in some Israeli attacks. So this is a concrete event, a concrete case of killing people in Gaza. But on the other hand, the whole event, the whole war in Gaza, which started in 7 October, is reported. Then the overall death toll is reported, and also the toll of the injured people is reported. So you have 2 events with 2 different sets of numbers and sets of arguments, and they're reported in the same news article. And so it is quite tricky, it requires some reasoning, and based on heuristics or text similarity, or there are no universal algorithms up to now how to really make difference between the events. That's not a trivial task, but that is required by event detection systems to make. In reality, what happens in reality is that these systems they basically capture just the main events on the basis of frequency. For example, these 58 Palestinians, 58 people, they repeated. So the system can say this is the main event where these 58 are mentioned, and so it looks around this number 58. and that it ignores the other parts of the text. So this is one heuristics which can be used. So this kind of heuristics, these rules are actually fundamental to build event extraction system, to aggregate events. And é manter contra o computer. Aqui na tua implementa. Acaso muito tudo vai te ensinar muito quiser tamanho. Muito se fala. Fugindo, orientar-se umas vezes para o chão.
Okay, so make a short break for the section. Later, so pick the problem. You can have some.
But I think that's cooking culture, maybe. It's so nearly that
That's true.
So we're getting on towards finishing, not towards finishing. This is the second part of the tutorial. Now, up to now, we managed to show what is the event template and what are the technology which underline the event detection, event extraction. So the event template, you have seen it, it contains time, location, victims, perpetrators, the numbers of the affected group of people, so how many people died, how many were injured, and also the template includes the weapons and the strategies used inside the social political event. And also it can include motivations, although it's more difficult to detect. And then we have seen that the main stages of the event extraction are name entity recognition, dictionary matching to detect, for example, event triggers in other maybe dictionary items, and argument extraction, so to detect the victims, the perpetrators, the time expressions, the occasions. And event classification is important. So to know what is the type of event, we need to classify the text. We need to say that this event is of type protest, this event is of type armed conflict, it is of type natural disaster, etc., etc. And then we have the event aggregation, which puts together the event templates. So as I said, the event templates are the event templates are not trivial to build because there may be many events in the same article, and there can be also different articles reporting about the same event. So these are the stages, the processing steps, and the event template. So if you're going to build a system which performs event detections, have in mind that you always should detect time, location, event type. Time, location, event type. This is the most important. So if you want to have event detection system, it must detect when, where, and what the event type. So the 3W are the most important. Otherwise, you don't have event detection system. It's something else. It is maybe useful monitoring system, but it's not event detection. Events are time-oriented things, as Donald Davidson says, that time is important to location also. And we have shown two paradigms, we have mentioned two paradigms of event extraction. So they are rule-based approaches, like grammars for parsing event descriptions, references to people, infrastructure, location, temporal expressions. All these are can be parsed by grammars. So the rule-based approaches they imply existence of grammars, domain-specific grammars, which find references to people, which find references to specific event phrases. Then, apart from the grammars, the rule-based approaches rely on dictionaries. So dictionaries of trigger expressions, dictionary like battle, protest, etc. Keywords or keyword combinations can be used in the rule-based approach to classify the events. So in the Europe Media Monitor and inside the Nexus event extraction system, we're using keyword combinations. So if you have the word protest and you have the word, for example, police or protesting or gathered or march, this is enough to say that the event is a protest or demonstration. Usually it's a combination of all four lists. So this and this or this word, and this or this word, etc. Now, these are the rule-based approaches, and these rule-based approaches are still being used. They're being used in the research publication about them, but above all um, in the organizations which are using event detection, the rule-based approaches are still being used. Still, in the research world, on conferences, on the world of conferences and projects, scientific projects, the data-driven approach, machine learning approaches, they have largely taken over, and then all the papers on event detection is about using statistical models like BERT, supervector machines, and they use for classification, for classifying sentences into one event class or another. And then there are the sequence labeling techniques like conditional random fields, Markov models, and maximum entropy classifiers, which are being used to identify the name entities and to identify the arguments. So on the place of the grammars, the data-driven approach gives us the sequence labeling techniques. And these are conditional random fields and Markov models and maximum entropy models. This is the case that the data-driven approaches are more written about, but in reality, in practice, the rule-based approaches give, if not superior, they give competitive or the same performance as data-driven approaches. And for extracting arguments, I believe rule-based approaches are still the main in the field of event extraction. Simply sequence labeling techniques are not intelligent enough. They require more data, sequence labeling techniques. Rule-based approach is much more easy to build for detecting dimensions of people and name entities. So rule-based approaches are considered to be outlived by machine learning approaches, but they provide, that is not true, they provide the basis for applying human expertise, because they're created by linguists, the rules. Then transparency, so because you can see the rules, you can see how they work and why they do not work, that's transparency. So it's important that you know that something is not detected, and then you go and you see the rules and which detect this type of name entity, for example, or person entity, and then you see why it was not detected, that the rule misses something, and then you can correct this, and it's called transparency. And then it can introduce feedback in the rule, so you can see the output of the system, then you can correct the rule set, and then you can see another type of output. And this is important because you can build a system which constantly improves. And with the data-driven approaches is like that you have a text corpus, and then you can play with the machine learning model, but you cannot make feedback, you cannot change the machine learning model, you can just retrain it. And that is it. So in reality, the both approaches are being used inside event detection. And both rule-based and data-driven and machine learning approaches are being used. The state of the art for text classification for classifying events are the BERT and the BERT-like models like Roberta or MuBERT, various BERT variations, fine-tuning on different text corpora, training and fine-tuning on different text corpora. And the latest development is using the generative large language models to perform event detection. So this is a completely different step because basically you're using another model like a black box, the generative LLM is not really under our control. So this is an example of a rule-based detection of domain-specific noun phrase, and it is built with a formalism called Express. This Express formalism was developed in the Joint Research Center. And we're detecting here a person group which is based on nationality and based on a quantifier. So it will detect this group, things like many Italians, several Bulgarians, many American Buddhists, and group of religious Jews, for example. And the person person group is called, the rule is called person group, and it contains several elements: word, part-of-speech article, word, part-of-speech quantifier, and then three dictionary items which are taken from a dictionary. One is person modifier, and this person modifier will be like, for example, religious would be person modifier, so adjective which modify people. Then you can have proper noun singular, like, for example, American, and then you can have the plural, which describes the noun, the name, which is the central for this noun phrase. For example, Buddhists or Bulgarians or Italians. So this rule, at the end of the day, exports a structure, which is a person group with a certain quantifier and a certain name. And they're taken from the words which are matched by the dictionaries, for example. And then this can be done on several levels. So, for example, another level, then after detecting the people, another level of the grammar is detecting the actions. So this level of the grammar takes the language structures from the previous level, so detected people, then combines them with dictionary output, for example, key phrases about killing or any other event type, and then says that if you have a person detected on the first stage, then you have a key phrase in a passive voice which is about killing, and then another person description. Then you have actor, perpetrator, which is the second, and the victim is the first. So this is done in this way. The argument extraction is done using the grammars. So the grammars are used to perform argument extraction. And then we know that there is a mention of perpetrator and there is mention of death, and the grammar basically gives us the arguments of the event. So this is rule-based event argument detection. And it is based on, there is a serious literature on rule-based event extraction, and the first system which were built in the 1980s and the 1990s were exclusively based on rules, everything based on rules. They didn't use any machine learning, any text classification, which basically appeared on the stage in the 90s. But before that, there are wonderful systems like RIS, which are still in the textbooks of information extraction, which are exclusively based on rules. And this literature is more recent. And for example, our center, we have published several works on rule-based event extraction and language domain-specific grammars. And we have also other works which are about rule-based event extraction. As a matter of fact, currently the rule-based event extraction is very largely used in bio-NLP. So in the biological bio-event extraction, we do not talk about social events. We talk about events which are interaction between proteins and interaction between genes, but they're still events linguistically. So this is still event extraction. And rule-based is the preferred technique there. This is the schema of the generic schema of the machine learning-based event extraction. So say most of the system classifies and they discover the events inside the sentence on a sentence by sentence basis. And so we have a sentence, so a couple of sentences. And then the first step is name entity recognition. Then there is a feature extraction. So feature extraction is name entity recognition, part-of-speech tagging as a second step, and the parsing. So many systems, especially in the world of research, which do not aim at efficiency, speed, and multilinguality, they use all these three stages: part-of-speech tagging, parsing, and name entity recognition. And these are considered features of the word features. And then these word features are being used to form vectors representing each word. And apart from this, the statistical systems are using word embeddings. They represent each word with a word embedding vector. And inside the word embedding vector, they also can insert additional elements like an entity or the part of speech uh, or the parsing or the part of the parser from the root to the word. And all these features can be mixed in different level of a neural network architecture. So this is very generic, so I don't speak about very concrete technology. Here I say basically how a machine learning based technology for event extraction is working. So you can mix these features using various different layers of neural network. You can try to build yourself vectors and then put them in a text classification model, neural network or SVM. And then the final stage is to infer the arguments and to classify the sentence or the text fragment into event class. So these are the stages. Feature extraction, representation of the text to numerical vectors, mixing the features and the vectors from the various stages, and then classification and inference of arguments and event type. So that's how the machine learning event extraction works in general. So this is very general architecture. So the first phase is the preprocessing and feature extraction. And so I'm going to say two words about how the data-driven approaches are doing dimension recognition, for example, and the feature extraction. The first step is name recognition, part speech tagging, syntactic parsing. And about part of speech tagging and syntactic parsing, we have these libraries, and this would be useful for you if that's how you can look at that. You can have these slides. For example, the Stanford Core NLP is very widely used for parsing, multilingual parsing. And it works in English, French, German, Chinese, Spanish, Italian, Hungarian, and Arabic. This Stanford Core NLP. It is considered one of the best packages and works works in Python. Then we have the Spacey. Space is also very widely used in the information extraction workflow. So Spacey does name recognition, part speech tagging, and parsing, and it does this for 23 languages. And there is the Natural Language Toolkit. It's a Python library, NLTK. It's a very used library, more efficient, more fast, but less efficient than the Stanford Core NLP. And then there is Apache OpenNLP, which does name recognition, part speech tagging, and also does parsing. So these four libraries are important if you want to do information extraction or event extraction, and you don't want to do from scratch those things because they're very time consuming to develop. So there are ready-made tools already which you can use for developing your own information extraction system. So there is a toolbox, especially in Python. So if you know Python language, you have very easy way to install any of these libraries and then to build on the top of them something more intelligent. And that's actually very important. That if only this is part of you remember from this tutorial, I think that will be enough. So machine learning for preprocessing, there are those sequence labeling technologies like maximum entropic learning, conditional random field, and hidden Markov model, which are based on final state like representation. Basically, they represent the text like a graph with arcs showing probability of passing from one word to another. And they're built with different level of complexity, and they're used to label sequences of text. And there now the state of the art is combining this with the output of transformer-based architecture. So transformer-based architecture builds abstract representation, and the CRF and the hidden Markov models on the top of the transformer-based output on the top of the contextual artworks embeddings is discovering the sequences of Um, so then there are the two technologies, the BERT and the BERT-like models, and the SVM and the other text classification models. And they're using to classify text into classes, and there are also some recent work which proposes to integrate pattern matching also in the machine learning-based event extraction. So this is recent work which shows, for example, there is work how to present both the patterns, manually constructing patterns, and the text using transform architecture into word embedding sequences, and then match them. So this is integrating the pattern-based approach with machine learning approach. So again, about this sequence labeling, it is the state-of-the-art machine learning technique for name recognition and for argument extraction. And as I said, there are transformer-based architectures, and combining this with transformer-based architectures, and then basically making this sequence labeling on the last field, on the last stage to discover the name entities, to discover the arguments. This is the state of the art of the document discovering technology, and there is this interesting paper, several recent advances in sequence labeling from deep learning models. And then we pass to the classification. Classification and extraction of the arguments. For example, there is this work of Raul Grishman and Gwen about detecting event triggers. Because, for example, if you have in the text just the word protest, that's not enough to say this is really a protest. This can be someone protests against something. So that's not a real protest. That's not event. So they built a multi-layer deep learning architecture which combines word embeddings, position embeddings, name entity embeddings, then mix them inside the deep learning architecture, deep learning neural network, and then as a final level, the deep learning architecture exports a vector, combined embedding vector, and then from this vector, the classifier is trained to say if word is actually event trigger or it's not event trigger. In this way, the system can learn if the sentence contains event or it does not contain events. So this is an important technology. And again, about the sequence labeling for argument mining, usually the corpora, the corpora which are used, the text corpora which are used to train such kinds of sequence labeling approaches, they're annotated with the below schema, annotation schema, and which stands for beginning inside and last token outside and user length chunks. So, for example, these 5 people were killed will be annotated like as 5 beginning people last, because here we annotate the dead people, the killed people, and it will be like that. Word by word, the words which are outside are O, and where the annotation starts is B, and the last token is annotated with L. So basically, the algorithms get these sequences where they say where the entity begins, where the entity finishes. And then they train the methods rely on maximum entropy, hidden Markov model, conditional random fields to build then the feature vectors and to perform name entity recognition and argument mining. And the final stage is the classification, the event classification. So event extraction system processes the text sentence by sentence, so by often they process the top 1, 2, or 3 sentences, and then there is feature engineering as part of the classification process. So all these name entities, embeddings, etc., they used to build vectors, and they using these vectors. We pass them to a deep learning neural networks like Bertha and Roberta, and then the text and the features are transformed. So basically, Roberta used to build from the features to build additional vectors, additional feature vectors, and then these feature vectors they used at the end to train deep neural network and derived to fine-tune derived model or support vector machine to classify the text fragment and to derive the event type. So the event types are derived using text classification techniques and intensive feature engineering using BERT, using name entity recognition, and as a result, we have a vector which is built out of these technologies, and then out of this feature vector, we are training a bigger we're training a text classifier. After we have built the vector of the embeddings and the name entities, so we have feature engineering we're using BERT usually and some large language models. That's the state of the art, and then we have text classification to derive the event types. So this is the event classification process, and then finally event template aggregation. So up to now, we sketched the most important part of event extraction, and the event template aggregation is the final stage. And probably this is one of the most important stages because it uses from the different parts, from argument in different areas, sentences classified into different event types. It should create one template or several templates. And this is an example how for example, about the complexity of this. So this is about, again, some Israeli strikes in the West Bank, and there are different numbers about the victims which the news reports. So this reports, this set of news, this cluster of news reports 4, 5, and 6 people dead. And we have used, the system is using gives preference to the last reported numbers, which is 6, but it also considers the other numbers to see if this 6 is close to. So this is the final template which then the event detection system outputs. It says there is armed conflict, there are 6 people dead and 2 people injured, which are children. This is the identities, to Israeli. And the snippet is this one. That's the snippet which contains most of the event. And there is also the place. So the event template aggregation finishes with this kind of descriptions, and then this kind of descriptions can be shown on the information system, and then can go into a database because there's structured representation of the news. So this is the final product of the event detection, the event extraction technology. You have a template which is semantically explains the events and what happened and what the participants. So it is in a way semantic description of the event. And there are many problems in front of the event template aggregation. I'll just mention them in this tutorial and just schedule solutions. And the problem number 1. One news article may mention different events, and for example, one article may talk about both the war of Russia and Ukraine. It can mention two battles inside this war, and it can also mention the whole statistics about the whole war. So there are 3 events: the whole war and the 2 battles. Then actually problem number 1 is that in one news article, event is mentioned in different parts of the article. So this is a very tough problem because apart from the part one article can contain many events, then one event can be put into different sentenences and then in different places, not in sequence sentences. And this is the problem. And then the same events can be mentioned in different news articles, social media messages. So we have here the problem of duplication and information overflow. So if you want to monitor the news and you have 1,000 news detected or 1,000 Twitter messages detected which mention the same and the same event, that's not really, does not save you much work. And this is one problem, that there are a lot of news sources which report the same event. So there are some solutions. So one solution is clustering. So we can cluster the articles and social media messages by their textual content. And there are different methods for clustering. There are many different methods, and the most recent one is they're based on LSA. LSA is used a lot in clustering. Then there are also textual embeddings are used, word embeddings are used as representing the text before clustering. Then one can decide to process only deleting sentences in the title in order to detect the most important event, which in the news article is clearly mentioned in the beginning. So the journalists usually mention in the top 3 sentences and in the title the most important events. And that's the choice of our event detection system. The Nexus is processing just the beginning of the articles in order to capture just one most important event. And then the other solution, another part of the solution is to take the most frequently mentioned locations, actors, victim descriptions, victim numbers, and ignoring the others. So, for example, if across the articles you have the word 58 mentioned 3 times, that's probably more important. So you take these arguments which mention the number 58. And I have basically left this part as a final one. Event classification taxonomy is an example of extracted events, because event classification taxonomy are a field on which are working linguists and experts in ontology, and even people from political science. They're working on creating classification taxonomy. So these classification taxonomies are not specific for the NLP, but they're more interdisciplinary resource. And this resource is being currently it is being created also by the scientists in political science. And without doubt, in the world of event extraction, the most outstanding taxonomy is the Conflict and Mediation Event Observatory, or called CAMEO. CAMEO was started in the 2000 in the University of Kansas with the financial support of National Science Foundation of USA. And then I wrote 2 well-known sociopolitical event data sets. In reality, there are more. So the most important are integrated conflicts early warning system, ECEWS, which is financed and maintained by the DARPA and is currently used by the United States military. This database of events, which used to be automatically fed by events. And there is the global event language and tone dataset, the GDELT, which I have shown on this map, and I'll talk after a while, show more about it. The GDELT is a very interesting project with hundreds of thousands of events, and if you want to train event detection, information extraction, or sentiment analysis system, the GDELT project is, because it's a public project with downloadable data. You can download as much as you want, geolocate in specific country. The only thing is it's automatically detected, so accuracy, you should see yourself how it is, but it is a very well-known project. And there was the Phoenix database from the Pennsylvania State University, and this Phoenix database, I'm not sure if it is downloadable. I think it is downloadable. And the ICEWS is also downloadable, but the previous events, not the current ones, because this is maintained by the military, and they just make public available, I think, only part of it. And this is about the databases which use the Camel taxonomy, and there are many other projects which use the Camel taxonomy. So this Camel taxonomy is very fundamental for the event extraction. And the event taxonomy objective of Camel is the called integrated data events analysis IDEA, and it was developed inside a project called Panda. So it's considered parallel to Camel, but in reality there are a few databases, maybe only one which uses the IDEA. Still, it is more detailed, I believe, taxonomy, but Camel is more widely used. And in the European Commission, during research center, we have developed the Nexus event, our own taxonomy. And this taxonomy is, you can just use it as an inspiration. We just use it in our system. And we have our own corpus, actually, which uses this taxonomy. So this is not important taxonomy, but we have a corpus built on the basis of it. So the Camel taxonomy, Camel codebook, that's something which you should see, because if you're doing event, social political event extraction, they're the most important event types. Like professors in sociology have sit together and they have created a list of the important events which are mentioned in the news, and they classify them into three-level taxonomy. And this is important resource for everyone who is working in the event extraction field. And these are the high-level types to which they came, and you can see that 20 event types, and that just the top of the taxonomy. So make public statement, appeal, express intent to cooperate, consult, engage in cooperation, engage material cooperation, provide aid, yield, investigate, demand, disapprove, reject, threaten, protest, exhibit military posture, reduce relations, coerce, assault, fight. These are the military security types in this coerce, assault, fight, and then engage in unconditional mass violence. So these are the top types. So I say this is something to which political and social scientists came to when they analyzed big amounts of news, and this is created in the Kansas University and then used in various databases. That makes this classification important. The databases of events which use this taxonomy. And I want even to go further to show some event types and subtypes to give you an idea how it looks like. So, for example, this the fine-grained event types of engaged diplomatic cooperation. So, number 5 is engaged, and number 57 is a signed formal agreement. So, for example, this is a very old news for about the Czechoslovakia and China signed agreement. That's in the 1980, and they're changing. So
maybe 5 more minutes.
It was like I can finish. No, not just up there. I can finish. Okay, so pass fast to this basically. Yeah, other great event types, physical assault, etc. Fights, support, okay, territory. Then there is our taxonomy, this nexus taxonomy, and you see basically we have divided the world of the events into social, political, crime, legal, targeted violence, and disasters, and also violence without specific motivation. So these are our event types. By social, political are military, unrest, humanitarian, and terrorism. These are the typical social, political events. I just give you an example of the nexus output you have already seen. For example, this humanitarian crisis, it detects the number of various numbers of affected people. This is another about deportation detected by nexus. This is another one about humanitarian crisis. These are two. Nexus can work in several languages, and so this is example in Arabic. This is in Spanish. And then just very fast about the resources. So this is the part maybe which you would like to see after the slides are published. Darklet event databases provides an event database which is manually created, and it contains the recent armed conflicts and cases of unrest and other political events. And when you go to this site darkletdata.com, you should go to the park data, and then you should ask via email about the credentials, and then you can download millions of records of events with text and fields about location and time and actors. And then there is the GDL which I mentioned. This is automatically created database of events in 100 languages, automatically translated from every country in the world. A very ambitious project. And important fields in their data. There are many more, but there is event class, date, 3 locations, the location of the 2 actors and the action, 2 main actors description, and event impact using the Goldstein index, and many other fields actually. And then we have our own EMM event corpus. So this is the link to the EMM event corpus, and this I provide just for you because it's still not official. So you can steal it until it is public, and they didn't notice it. That's a very nice corpus. It's of tens of thousands of events, and actually about 500,000 events in English, 10 years of data in English language. So you should use this link until it's active. And this example from the corpus event type, it's manually curated part of it. So the risk tag, date, URL of the article, the place with the coordinates, the passenger number. And then there is the event stock event corpus, which is available from GitHub, and it's created by Pierre Vossen and Tommaso Caselli. And there is this paper, the event story line corpus, where you have events which are connected with causal relations. So that's a very interesting resource also. And of course, our case workshop. This is the workshop where we also provide corpus for the participants in the shared task and for the very interested researchers also, believe. We have Twitter channel, website, and also provide the corpus if you participate, especially in the shared tasks. And that's it. Thank you. So, questions?
I have only one quick question. Has this ever been done in the state of Bulgaria in the past 3 years?
You mean a research on the political state of Bulgaria? As far as I know, there is no specific corpus of the political state inside our country in the last 3 years.
What about media manipulation? It comes from me. I'm over here. What about the media manipulation during that time?
Media manipulation. Let's say I can talk about our event extraction system, Nexus, which is working on the top of the news media monitoring in the GRC. So we're capturing the news from very official sources, and usually we work with news which is repeated at least twice. So if it's not repeated twice in 2 different news sources, we do not extract events out of it. So we have this clustering, news cluster requirement. You must have a news cluster in order to extract event out of it. There's at least 2 news. So if it's a fake news, it will probably will not appear in many sources. If it is widely propagated fake news, many manipulations, let it be. It's not our. It's a problem of other people, not people who monitor the news.
Thank you.
Yeah, you're right. You're right. Not everything in this system is true. There is manipulation, of course.
Yeah, so I wanted to know whether it's tracked, whether it can be used for that, whether you can actually help clean up certain media manipulation is very persistent in Bulgaria.
Because you're not talking about fake news detection, right?
Not only.
Because for fake news detection, there are systems, and these systems are using these web validation websites, and basically they are authoritative websites which are publishing the fake news and debunk them, including I think for Bulgaria. So they study basically this news, if it's repeated, if it's confirmed, they look at alternative news sources and social media comments about it. Mostly authoritative sources. That's what's the technique. There's no way that you get that you know if it's something true or not just on sitting before the computer screen. There's no such game. It doesn't exist. It's the computer is computer. I mean, if you should be in the field to understand what's going on, that's the only way to get the real truth. If you talk about this.
No, I'm looking at more from a perspective of people that aren't very educated on the topic.
Fake news detection techniques, and debunking websites. That's the answer, and I don't know anything else.
I can see. Anyway, so I'm afraid that the time is up, and it's good to have some break before the next one. I would suggest that if you have any questions, because I also have many, please use the break now, and maybe also then the lunch break, and also during the conference. I think Hristo is here, right? So
Yeah, I'll be here, and you can use my email also if you want.
yeah. Okay, so I would like to thank you very much for the really interesting and inspiring course. And I'm sure that we will approach you, and yeah, there will be a queue for you. Be aware of that. Thank you so much.
Thank you very much for being among you. Thanks. Сега може да се изключи, да мога да I have the pleasure to present you the next speaker, which is Professor Petya, who is Professor of Contemporary Bulgarian Contemporary Grammar in the Sofia University. She is also a senior researcher in the Department of Linguistic Modeling and Knowledge Processing in the Institute of Information and Communication Technologies of the Bulgarian Academy of Sciences. And I know Petya from at least 20 years, and we have developed very interesting technologies together. And I think she is one of the best researchers in the field and reference point for syntax and grammar in the Bulgarian language, especially. So, Petya, the floor is yours.
Thank you very much for the presentation. Yeah, I'm very happy that in Bulgaria there is a very, big group of very successful people in this. So modestly, I'm one of them, I hope. So let's start. My idea is as follows. In the first part, I would like to introduce you to the more basic things related to these resources, syntactic resources. Maybe some of you are more acquainted with them, but maybe some of you are not. So I prefer to go with this. And then in the second part, it is something that it is also new for me. I would like to present you some works, how syntax has been incorporated in the big language models, what the problems are that have been addressed, and so on. And also part of our own work up to now. So yeah, that is my idea. Okay, so as we can see, First, I'd like to give you some brief intro into the syntactic corpora. What are they? Then, very briefly, of course, about the two main approaches that are now available, the constituency-based and the dependency-based. And we'll see that the dependency-based is the one that is prevailing at the moment. But you will also have an invited lecture tomorrow by Joachim Nigel about the dependency, universal dependencies. So my idea is just to briefly go through this and only if there is time, but probably not, to get into details. Then the types of syntactic corpora, the challenges in converting resources from one of the frameworks to the other, and some conclusions. Okay, so even if we know what a tree bank is, I think it would be useful to see actually what the definition is behind it. So it is a corpus annotated with syntactic annotation. This is the very basic definition, but of course it is more than this. So first, this is the information in the annotation is added or checked by a trained annotator. They started with manual annotation, and what is very specific, the annotation should be complete. Because if you go and see the grammars that you read, for example, for a language, you can see some examples, but usually when there are some marginal ones, they might be not there, right? And you might just say, okay, how I should analyze this one. When you have this resource, you cannot skip anything. You have to have a solution, even not the best, even not the most elegant one, but you should go and do this analysis. So the annotation should be consistent. I mean, if you have one solution for something, you should be consistent with this, even if it's not a good or the best solution. And later on, if you decide to reclassify it, then you can do consistently as well. And okay, the primary format of this annotation is the syntactic tree graph. We will see now what it is. Okay, just example syntactic trees from Wikipedia. It is from Wikipedia because just to illustrate the two main approaches to modeling the syntactic information. On the left, we have the typical constituency one, and on the right, you have the dependency-based one, which is flatter than the one on the left. And of course, there are also other differences, but also similarities. Okay, so what is pro and con concerning constituency and dependency? Again, very briefly, constituency is very easy to read. It corresponds to common grammatical knowledge, the phrases, which is good, but it introduces some arbitrary complexity. The dependency is more flexible. And maybe you know that it is very welcomed for languages that have a free word order. And in that respect, it is flexible and also corresponds to common grammatical knowledge, the grammatical functions. So the focus here is the subject, the complements, the adjuncts, and everything that goes as grammatical role or function. And also, one thing that is not good, it is the problem with headedness. We need some consistent criteria to have a head. And sometimes, and some phenomena are not very okay with being analyzed as headed phrases. But here, always you have to indicate which the head is. So, trees and graphs. A graph is a set of vertices or nodes and edges, And the tree is just sub-graph, so to say, connected graph in which each node, except one, has exactly one parent node. The labels, the nodes and tags can be labeled. Okay, the term tree bank obviously comes from the assumption that this information can be presented as a tree. However, the reality shows that we actually do not present the syntactic knowledge as trees, but as graphs, because it's more complex. And always with the pure syntax, we want to put some more, like it was mentioned in the previous course, like the coreferences or the named entities and the links. If the language is pro-drop, like Bulgarian, for example, and other Slavic languages, we would like to indicate these relations. So yeah, it is more than a tree. And just brief examples with one of the classical tree banks for English, of course, a Wall Street Journal. It is constituent based, and also you can see the bracketing representation. Of course, in order to understand what it is behind, you should also have some knowledge about the annotation scheme, because otherwise you cannot decipher it. Another example is, apart from the bracketing, you can also have this tree representation. And it is interesting because here you can see that I shot an elephant in my pajamas. My pajamas is connected to the verb, but here in the dependency tree, you can see that it is connected to the elephant. And so this is one of the most common ways of presenting the dependencies. So the governing head. So we have an arrow that points to the dependent element. And that's in that way, we can see that shot is the head. And then on the left, you have the subject that depends on it. And on the right, it is the object, which is elephant. And then you can see that in is related or connected to elephant as nominal modifier, but not with the verb. So it's just the other analysis in this representation. And very often it depends on our view on the grammar, because here you see that pajamas is the head, not the determiner, as usual in the theories. And I'll say more about it in a second. Also, just to see other tree banks, how they look like. This is the German tuba desert tree bank. And here, what is the interesting representation, that you have the different way of presenting the syntactic labels, like MP, VP, and also the functional ones, which point the clauses and everything like this. So Germans are very, very unique always, and even in the syntactic theories, they have a special theory with the middle field, forefield, some fields like the initial, in the middle, and the end. And I think it was invented by a person who is even not a doctor, not a PhD. And this theory is very influential, and it covers all their, view on syntax. Okay, another way is the constraint-based grammars that produce also syntactic trees. And here it cannot be seen, but in the next slides you will be able to see. One such theory is LFG, Lexical Functional Grammar, and I like it very much, although I never worked in this framework. But it combines the constituent view and also the functional view, and you can see both, and also the connections, the relations between them. Okay, so here you can see the labels in these two representations. The flatter one, where you can easily read the sentence below, and also the one that in which the words are, floating everywhere. Okay, so if we go further in LFG, as I said, they have the constituency C structure and F structure, which is attribute matrix, value matrices. And as you see, they are very complex ones. So usually these formalisms are very, very strong. I mean, they are really the best. However, they are very complex. And in reality, always the people who develop their tree banks in this formalism, they always live with dependencies in the end, because it's really complex representation. Okay, so we now go just for a while on a more abstract level of viewing the things with the tree banks. Let's see how we model the language knowledge. First, language is a natural phenomenon. It is very difficult to formalize. And the good news about it is what? That we have work to do. And we will always have work to do because we never ever will be able to formalize it completely, right? So then we have the language model. It is a mathematical model, abstraction over the language that already works with mathematical objects because we cannot see a noun or a verb or a subject and so on. These are constructs. And the relations among them. The linguistic theory is the mechanism that gives us our grammar to the language. Because, there are different linguistic theories, and each linguistic theory tries to prove that it is the best. How? Analyzing, for example, languages in Polynesia or other very rare languages in Peru and so on. But in reality, no linguistic theory is perfect. A tree bank can be defined as a subset of a language model with respect to some unknown linguistic theory. And then when we have a specific linguistic theory, we try to apply it to the language. Okay, so the language model, as we said, is an abstraction over this natural language, and usually it's represented as a set of trees. A sentence representation is a sequence of words associated with a tree, and then a tree bank is rather a set of graphs representing sentences from some natural language. Okay, and so about the ideal grammar and the tree bank grammar. Of course, the tree bank grammar aims to become an ideal one, but it can only approximate that. It can never be the ideal one. And here we have some terms like formal grammar is a formal device that for each sentence it predicts whether it's grammatical, belongs to the language or not. And if it belongs, it assigns some structure. An ideal grammar is this grammar that predicts the language with very minimal over and under generation. So not to end with structures that do not belong to the language, but also not to cover only small part of the language. And of course, as I said, we haven't invented the ideal grammar yet. A tree-bank grammar is a form of grammar that generalizes over the sentences in the tree bank. So it is not the whole natural language, but the data that we have. And if we have to visualize it, we can visualize it like this. You can see the natural language, which is very messy. then the ideal grammar that tries to cover exactly this messy thing, and then the tree-bank grammar that can solve part of this, but not everything. It covers, it could over-generate a bit or under-generate a bit, but never could be the best. Unless, of course, we work with the controlled language. If we work with the controlled language, we can, of course, model it easily. Okay. So, in order to have a tree bank and to apply some linguistic theory, we should have an annotation schema according to which to annotate it. And this annotation schema is actually the grammar behind this resource. But it could be implemented at least in two ways. One way is to be implemented as a grammar, like, for example, the English resource grammar in the theory of HPHG. There are such grammars also in LFG, or Norgraph for Norwegian, which is LFG based. So these grammars, they usually developed for languages that already have advanced resources for formalizing their language, and then you can produce computational grammar. But, for example, in our case, it was the opposite. First, the annotation schema was developed with the development of the tree bank. And we only could use preprocessing. Hristo already said about the preprocessing. If we have the part-of-speech tagger, named entity recognizer, and chunker, the shallow syntax, basically we can have some good initial point to attach the final phrases already into a tree bank. So we could have, in the first case, tree selection, when we have a real computational grammar for a language, and in the second case, we have a tree creation. So I had the opportunity to work in both ways. Okay, so the life cycle of a tree bank in general is a design phase, implementation phase, validation, documentation, exploitation, and reclassification, because when you use something, it's always not perfect, of course, and you find new arguments in one or another way, so you can reclassify your resource. And that's why for the, I think for the Dutch tree bank, Alpino, they put on their website who to blame, okay, about the tree bank. Not who to praise, but who to blame about their decisions. Okay, so in the design phase, of course, we can make a tree bank just for the purpose of having a tree bank, but if we want a more focused exploitation phase, then we should know the goal of this tree bank. Then how deep knowledge would we would like to have into the tree bank, and also the format, because although nowadays it's not a big problem to change the formats into from constituency to dependency or from one dependency format to the other, still you can lose information and also some kind of phenomena. Okay, the result from the design phase is a style book describing the annotation scheme. In case of the tree selection annotation, it describes the discriminators used for the selection of the correct trees. So what happens here? I have a computational grammar, and it parses the sentences, and then all of a sudden you have, let's say, 100 candidates for a sentence. We cannot imagine even how many ambiguities are produced by this for any language. And then if we have this mechanism, then we should have good way of discriminating to say, okay, if I have masculine and feminine in the adjective and noun, then I cannot have a phrase. It should be discriminated in some way. And this is true, as I said, for the computational grammars. Then, in the case of tree creation annotation, then we should look for another way of validating. In our case, it was a DTD in XML, and what is in red, then it's maybe not okay as an analysis. But of course, it is not enough. Okay, implementation phase. We should identify the sources of information which support the annotation process, whether it's a grammar implementation or just preprocessing plus full syntax that we want to annotate, the architecture, the software, the organization of this annotation. And here we could have the text corpora, partial grammars, the chunkers that are very important, general linguistic analysis, grammar books. It is very important. In our case, we consulted all the books that were available at the time. Validation phase, it requires consistency checks over the whole tree bank. These checks determine the conformance with the principles of the style book that are followed and the agreement among annotators. And of course, here we could have two problems. The style book is not good enough, and then the people cannot annotate well because it's not clear what to do, or the phenomenon is very complex, and then the annotators could have different opinions, but they are correct. And then in our case, we had some preference rules. We could say, okay, both are correct, but please prefer this, but the other is not wrong. The implementation phase, always important, not only for tree banking, but in any application. It should register the current state of the tree bank, and of course, then the people would know what the development is based further and how it might be used. It is again the style book, the analyzed phenomena, the description of the annotation, and so on. And exploitation phase includes the actual usages. Of course, as we already heard, it's not only the linguistic research. When we started, we thought, okay, we will just do it for linguistic research. Tree banks are far more useful for many other applications than just linguistic research. In digital humanities, we saw that in event extraction also, and other very useful applications. Okay, for creating other useful language resources and so on. This phase reclassification is very important because, as I said, you can never have a static resource. I mean, you could have it, but it's not good because you add more sentences in the case of tree banks, or you find out that there is a better analysis for some phenomena and you'd like to change it. So it is a dynamic one in this sense. So you could have a creation of a new annotation schema, new data, adaptation to the represented linguistic knowledge. Because when we had to transfer our tree bank that was constituency-based to dependency-based one, then all of a sudden, because it's a multilingual context, we had to conform to decisions that we don't like for Bulgarian, right? But it is always kind of a compromise whether you'd like to be comparable or you'd like to be more faithful to the traditions and the ways you believe your data should be analyzed. So it's a big problem for the people who have to do it. Okay, so the encoded linguistic knowledge, it is not, you say, okay, it's just syntax, but until we just go to the syntax, we have many other things to do before that. It is morphosyntactic information, especially for the rich languages like Bulgarian and other rich languages. The named entities, many tree banks now have also the coreferential chains within and across borders of the sentence, semantic rows and senses. I mean, the richer the tree bank, now the better. So the prerequisites are related to what I said. It would be nice to have these modules already available for a language. Of course, nowadays with the big, large, huge language models and techniques like zero shot and few shot and much work done within the similar languages, maybe it's not that crucial, right? Initially. But at some point, if you don't have the good resources for your language, it becomes crucial. I mean, you can have something initial, but you cannot have really good model without resources for your language. Okay, and here just briefly, I'm just mentioning, but I'm not going into that, about these problems that go before the sentence boundary detection, which is not trivial, of course, especially in dialogues, in direct speech, and so on. Yeah, then to decide what should include the syntax that you analyze with. This is, of course, the syntactic domains and PVPPP, but also maybe functional labels like the clauses, domain clause, the embedded ones, and also the pragmatic elements, discontinuity, and other phenomena. And also semantic rows, discourse information, temporal information that is included here, and so on. Yeah. So here, another thing is very important, the full syntactic analysis versus chunking. Chunking is the shallow grammar. Here, it is embedded by Avni. And I like this term, islands of certainty, because you get just smaller phrases, but they are sure phrases. And why it is very important? Because, for example, grammars that use HPSG and LFG, they are lexicon based. They are lexicalist theories. If the word is not in the lexicon, then all the parse fails. And you would like to have some phrases from this sentence, even not all of it, and not just to have, okay, this sentence is not parsed, it's failed, and so on. So that's why it's good to have these chunking non-recursive structures. And the precision is favored to coverage, of course. And just to mention that now, although the tree banks, and we believe in that at the best, that are manually constructed and analyzed, we also have these parse banks, automatically parse text when we already have parsers, and we have some syntactic structures. At the time, the metaphors were garden, so the manual tree bank is a garden. Then we have a forest, if we have automatic parsing, but then some checkings over the resource. And jungle, if you just parse and not look into that. It was very nice metaphor. And apart from parse bank, we also have another term, cache bank. Yeah, it's really, really automatic and nothing is checked there. Dynamic bank is the best one, I think, but it is related to the computational grammars because you can just construct your grammar and check immediately how it parses and just to correct if there are any errors. I did that for Bulgarian, but my grammar at the moment parses 200 sentences reflecting different phenomena. And usually it happens, you repair one thing and then you get another problem. And again and again and again. And so I have this experience, I'm lucky. Okay, challenges. Syntactic domains and ambiguity. Of course, if we want to compare with other languages, this is a problem, a linguistic phenomenon. Whether we assume that this one is the same phenomena in the languages or different. The critics, are we the same with the Romance languages or not? And things like this. And relation to other linguistic levels. Whether we have monostratal or multistratal approach. Monostratal is you have everything at the same time, which is HPSG and LFG. Just it's very as I said, strong, but it's very complex. Or you have different levels and you have mechanisms to relate them. I tend to, I don't know, I worked in the first one, but I tend to like the second one. I just some example with ambiguity, but we already had this. And of course, this structural ambiguity cannot be resolved on the syntactic level. You need ground knowledge, you need knowledge about the context, the discourse, knowledge about the world, to know maybe statistically it can be selected, to know that is more often you buy cars with some money, but you don't buy cars that have money in them, right? Although it would be really nice, but not typical, not probable. Yeah, and I already said some words about precise grammar, this computational grammar. It is really so precise that if, as I said, the lexicon doesn't have this word or your rules do not have this rule, then the sentence cannot be parsed. But they are very powerful. So such a grammar, I know that it was developed for English, but it took, can you guess how many years for a precise grammar of English? English, not a morphologically rich language. 30, more than 30. So there are good grammars for Japanese, for Norwegian, and I told you how many sentences my grammar can parse. Okay, so again about constituency and dependency, phrase-based, word-based, both have problems, common problems, and also both are connected. Because from words you can make phrases, and phrases very often have head words. Okay, so the constituency, we have the pantry bank, as I said, and I also mentioned the lexicalized grammars as constraint-based, but also the categorical grammar. They're also, I'm not so familiar with this framework, but also a lot of work is ongoing there. Okay. I think I already showed this. The thing about LFG and HPSG that they have this, especially LFG, this connection with the functions and the constituency tree. And HPSG, you can see what a matrix is just for kin walks. You can imagine if it's from media, some sentence, you can, you know, 3 or 4 levels or lines, it will be look like. And that's why the people who used it, again, I think the Dutch, they just ended up with dependencies. Okay, so yeah, in the dependency-based tree banks, it is important you to know more about the universal dependencies because it is now the state of the art. But I always want to mention the Prague group because they were the first to inspire into dependency parsing and rebanking. Just to see how their tree looks like. It is multistratal because you have all the levels from the words to the top of the tree, dependency tree. Universal dependency, you have more possibilities to see what it is. Yeah, and maybe just 1 minute to go very quickly through the myths and the reality, and then we finish with this part. Myth, a tree-bank can be theory neutral. No tree-bank can be theory neutral. It is always theory dependent, but it could be more light or more depending on the theory, right? Then we can always convert safely the resource from one theory to another. No, you can lose, as I said, information or ways. There are not good ways to tackle the problematic phenomena like coordination, for example, relative causes, and so on. We do no, theory complexity doesn't influence the tree-bank presentation. It does. I mean, if it's complex, it's complex. So HPSG and LFG, they are very good for the machines, but not for people, and the other way around. Okay, so the term theory neutral doesn't mean without any theory. It means that another level of annotation is developed that is applicable to any language. So it is really a light version of syntax, but not just neutral. And yeah, here you have the universal dependencies with the theory. And I can tell you that one of the most difficult queries is the syntactic based query. Because it's powerful, but it is difficult to model this query in some language. And for that reason, for example, I like the best is GRUMACH, let's say, mechanism or system, because they give you by example. You can just choose what you want and get the subject or subject and object or something like this. They have a matrix and you can just choose what you are interested in. Otherwise, you have to really invest your time to know how to do this query to get some syntactic structures. And this is just the current situation with universal dependencies. Just yeah. And in conclusion, we see that at the moment the dependency tree banks are dominant and the parsing dependency is dominant. So it's good that tomorrow you will listen more about it. And also, there will be in the afternoon, I would like to say about the afternoon course by Verginica and Ivelina. There is current cost action Unitype that combines universal dependencies with parsing of multi-word expressions. So they will present to you the really latest achievements on that, which is very nice because everything is related to each other. Okay, I stop here. Thank you very much. And in 15 minutes, come for the second part. Thank you. Yeah, I prefer problem. Okay, I think it's time for the second session of this course, and then we have lunch break. So I have to do my best to have your concentration on me, and then lunch, and then a very, very interesting course in the afternoon. Okay, so I must say that what I will present now, I'm not sure whether I will have time for everything, but let's see how it goes. It is also new for me. I mean, it was really new things that I wanted to consult and find. So I will just present to you from the point of view of a linguist, not of a computational linguist or, programmer. But I think it's very interesting. So now we go to the point why syntax matters in the era of large language models. When many people think that, okay, we solved everything, why we should care about knowledge about natural language. It is not true, of course. This way, now. Oh. Okay, so basically I'm doing some overview of papers that I found when they try to incorporate syntactic knowledge into large language models, but in different way. Okay, and then if we have some time, I'd like to present some work of ours, but it is under review, so yeah, just of course any feedback is welcome on that. Okay, so large language models and syntax, ways of incorporating syntax in these models, parsers versus large language models, some in-house experiments and conclusions. So most of these papers actually are in archive. So you know that nowadays they just hurry to put them there just to have their ideas reserved. And some, of course, are published. But the first one is how well do large language models understand syntax? It is over-generated meaning of understand, but anyway, an evaluation by asking natural language questions. Okay, let's see, I always give the authors and the link. But until when you get the slides, you can just follow and read more. And don't be surprised, most authors are Chinese. Okay, so what happens? As per boxes, they are research questions. Do these models truly comprehend human language, or do they complete tasks by memorizing surface-level lexical patterns? Do these models understand sentences based on syntactic rules, or do they treat language as merely a bag of words? Whatever I can catch, and that's it. So their approach is question answering templates that they use to understand. So they target 9 syntactic knowledge points, we will see that. And they believe that they are more closely related to sentence comprehension. Experiments conducted on, you see, 24 large language models. They suggest that most have a limited grasp of syntactic knowledge, what we already supposed, exhibiting notable discrepancies across different syntactic knowledge points. So it's not easy for them to understand syntax. In particular, questions involving prepositional phrase attachment, they pose the greatest challenge. Not surprising as well, because sometimes for humans it's difficult. Whereas the adjectival modifiers, indirect objects are relatively easier for these models. Okay, again, their findings and methods. They did a case study on the training dynamics of these models, and it reveals that majority of syntactic knowledge is learned during the initial stages of training. Why this is important? Because nowadays we believe that the more data, the better. However, the authors say maybe it's not the silver bullet, maybe it's not the best thing to do. Maybe we need more non-homogeneous data, but not more data always. It's interesting, actually. Two main approaches, probing and prompting. Probing requires access to hidden states of the algorithm of the model, which are not available for these API models like GPT series. Prompting requires designing of complex prompts, we already know that, and sophisticating decoding methods. And also there are literature on that. Okay, so as I said, authors use a question answering approach. And they said, okay, we have three types of questions and templates, true, false, multiple choice, and fill in the blank. Like we test some human. Findings indicate that while most language models have a partial knowledge of syntax, GPT-4 demonstrates exceptional superiority. So this is the winner, according to them. For as data, the constituency trees from the pantry bank were used. So mostly, of course, here the work I present as an overview is on English. I found one paper also on Chinese, but I didn't have the time to go through this very well. But they also investigated different phenomena, how they are grasped by the language models. But since I don't speak Chinese, I decided not to. Okay. So here you can see what they use actually. From the syntactic point of view, grammatical subject, subject complement, direct, indirect object, main verb phrase, adjectival modifier, adverbial, and it is interesting also to address coordination and prepositional phrase attachment because they are really very tough for any theory. And you have the numbers and also some examples of this. Okay, so the experiments, as we said, were conducted on 24, I mean, many experiments, many models, but these models were from 6 families. And here we can see Mistral, Batch 1, 2, Falcon, Llama and Llama 2, and ChatGPT, which is good because we can see how they behave. So, as we said before, the winner is ChatGPT. And if we go per type, true or false, and multiple choice, and fill the gap, what we can see, except the fact that it is the best, and the second best is GPT 3.5. I think that the best type was multiple choice, if I remember correctly, and the other are not so well. And the worst, of course, is fill the gap. Okay. If we go through syntactic phenomenon, per syntactic phenomenon, which was grammatical subject, direct object, before that it was subject, object, and indirect object, and so on. Again, we can see that the numbers for GPT-4 You can also see the averaged numbers, which is also good indication of what is difficult and what is not. So for this GPT, which is the best, from what I see, it's indirect objects, it seems, which is interesting. And the one that is worst is the adverb, which is very interesting. Of course, it's related to prepositional phrases, but it is interesting in our data, in our experiments. Again, one of the problems were adverbials, which I didn't expect, but obviously there is some tendency on this. Okay, so this was very brief indication on this paper. And now we go to another problem. Explicitly modeling syntax in language models with incremental parsing and a dynamic oracle. Okay, let's see what these people do. They propose a language model already. They don't test it, but they just propose a new syntax-aware language model, which is called syntactic ordered memory. From what I understood, this ordered memory already existed, and they just built on this. Okay, it explicitly models the structure with an incremental parser. So we need a parser as well, not only model, and maintains some conditional probability from left to right. So it ensures that we go more or less with the standard parsers that we have for a language. Okay, so they train an incremental parser and thus they avoid bias. But on top of that, they also use dynamic oracle to predict the next token, what comes next. And to prevent more or less the model from wrong decisions. And what is the moral here? Experiments show that this syntactic model, ordered model, can achieve strong results in language modeling, incremental parsing, and syntactic generalization tests. And at the same time, it uses fewer parameters. And we will see that it is best on the not on the common phenomena, but the more rare phenomena, which is also interesting. It's good on the more difficult ones. This is something that we already know. So I'm just marking it here that most language models are good at capturing frequent syntactic structures. It's not a problem, but they do not generalize, for example, with long distance phenomena and things like this. So these people want to address this issue. Okay, the proposed model acts, as I said, as a language model, but also as an incremental parser. It inherits the syntactic representation, which is used in ordered memory. And here there is another line of literature that is there, in which syntax trees are embedded in some memory representation. So they embed this knowledge. And if the ordered memory itself is unsupervised, so no data was used to train a parser or a model, this syntactic ordered memory is explicitly trained to predict the syntax trees incrementally, and also they use partial syntactic structures. That's why I said that maybe with these large language models, we slowly go back to shallow syntax before we go to the full syntax again from the 80s last century. Okay, so what does it do next? It factorizes the next token prediction into two steps. How it predicts the next token. First, the attachment position is predicted for the next token with some zero-step look-ahead parser. I'm not specialist in parsers, but obviously we should have one in order to apply this technique, trained on a data supervised fashion, and then the next token distribution is predicted, partially predicted structure. Okay, so from the partial knowledge, we want to get the full tree. Again, data is from Pantry Bank, and there is another corpus that is based on Pantry Bank, this Bulgarian, which is a large Pantry Bank style parsed corpus of, you see, 24 million sentences. Maybe that's a jungle, maybe that's this parse bank, cache bank. But they use it very often, I saw through the papers. Okay, it's not well visible, but here it shows that on various phenomena like long distance embedding, center embedding, which was the main sentence and the clauses to detect with subordinators, complementizers, and I cannot see the other things, but they are also such phenomena that are licensing and yeah, this kind of phenomena, they are very well captured by the model. On the contrary, the adjectives, for example, which was the first one, the agreement, is not captured well. I mean, it's good that the model can do well with rare or difficult phenomena, but maybe it's not good that it cannot handle at the same time the more typical structures. Okay, another one. Tree-planted transformers, I think, yeah. Tree-planted transformers, large language models with implicit syntactic supervision. So there is another way. Yeah, the first paper was basically to test how the models understand syntax, and these ones are basically how we could implant somehow syntax into that to become better. Okay, so they say the following. Syntactic language models can be trained efficiently to reach relatively high performance thanks to syntactic supervision. So here we always have data, I mean, tree banks that we should train this model on. But they have trouble with scalability. So it is necessary to develop an architecture that can combine the scalability of large language models with the efficiency of the syntactic language models. So to take the good features from both. And that's why they call it syntactic large language models. Okay, so their method is called tree planting. And they say we implicitly plant trees into attention weights of transformer. So this is within the model to reflect the syntactic structures of natural language. Transformer is trained with tree planting, and it is called tree planted transformers. So already they know something about syntax. And the good thing is that this model can learn from small tree banks. For example, our tree bank is small, like 200,000 trees. It's tokens and 15,000 trees. But nowadays, you should have like minimum million trees to work with. But it's good that you can learn on small tree banks through this tree planting method and then to apply it on a corpus and to scale it up. Okay. So this model, transformer with syntax, despite the lack of explicit syntactic supervision, they say outperforms various other models with explicit syntactic supervision. So I understand that if you implant this knowledge into the model, it is better than if you train it on the data and just use it. Okay, and I think that this tree planting method is promising one. Okay, the data is some data set that can be found there. And you can see again this big corpus on tree bank, this big one. It's very simplified way what they do, but the details are in the paper itself. So you have a small tree bank with some analysis, and then, of course, you can say, okay, sync is the root, and every other word depends on it. Of course, it is very simplistic way, but when you learn in this way from the tree bank, then you can go to a corpus without structures, for example, dogs in a yard play, and then the model can say, here, play is the root, and all the other words depend on it. There are also, they estimate also the relations between the words themselves, but it is in the paper, just for you to know. It is the simplistic view. Okay, so nowadays it's always good when we do something to say explicitly our limitations. And in the big conference in computational linguistics, they always do that because, of course, we never can be the perfect ones. And they say the following: what the limitations are. These big models are trained at the document level. I mean, usually the large models are trained at the document level, but the syntactic language models are trained on the sentence level. So there is some discrepancy on that. And the annotations in tree banks are really sentence dependent. So there should be some way to make them work together. Also, their evaluation was also limited on the syntactic knowledge benchmark and perplexity, but there are many other ways of evaluating whether this model works well or not. And they think that the development of a novel continual learning method would be necessary also for scaling this model. So it's not only data, we need also algorithms, we need also methods. I mean, not easy, obviously. Okay, the other one is incorporating syntax in pre-trained language model using some optimization. And the idea is just to prevent the model to forget too quick, maybe. And let's see what they do. Okay, here the authors explore additional training to incorporate syntactic knowledge to a language model, and here they use BERT. They designed 4 pre-training tasks that learn different syntactic perspectives. For example, to predict the dependency relation, phrase detection, also main subordinate classification and coordination. Again, it's interesting because coordination is not easy to model. The data here already is from the universal dependencies tree banks. We also use this one for English because it was comparable to our tree bank. The following types of sentences were removed as noise. Sentences when they are less than 5 tokens, sentences containing foreign languages tagged as X, sentences containing undefined dependency relations, like a very general one, dependency. So very often you have to clean the data. And here, just to see what happens about all these relations, they just apply different optimizations functions and Adam something is the best one. Optimizing, yeah. But as a whole, I think even if we look at the other ones, they are all good, more or less. Even for coordination, which expectedly is the worst one, it's good. I mean, these numbers seem good to me. Okay, so this was really a very short overview of the papers I found related to how syntax is incorporated or tested in relation to large language models. And of course, I wanted to prove that this knowledge is essential and tree banks are important. And yeah, that's why I just made this overview. Okay, in our case, what we try to do is to introduce shallow syntactic information within graph-based dependency parsing. And there are some experiments that we have done. Of course, there is more to do, but I decided that it's good to share with you the recent things that we are doing. And of course, as I said, any feedback is welcome. Okay, so here a new BERT model fine-tuned for parsing Bulgarian text is introduced. This model is extended with a new neural network layer. So this is basically manipulation of the model itself. And the idea is that we want to incorporate some shallow syntactic information during the training phase. And the results up to now show statistically significant improvement over the baseline. Not too much, but statistically significant. The architecture has been designed and tested for Bulgarian, but also for English, because we wanted to show that this method works also for another language. But as I said, there is more to do. Okay, so dependency parsing has been extended to accommodate some predefined shallow dependency information. That is the new part that we import into the model. The predefined information came from two sources, lexicons, valencies and multiword expressions, but this is really very modest one because we concentrated on the fixed multiword expressions, not on the really heavy ones. So it is just initial work. And shallow grammars, chunkers, where we have developed at the time our own chunkers, some NPs, VPs, and so on, and we could use them now. So we have some partial dependency trees, and for example, in the partial grammars, for the critics with the verbs and noun phrases that are sure, and so on. Okay, implementation. The dependency parsing that we use is based on large language models. We follow the approach of McDonald, which is from 2006, about the graph-based dependency parsing. And what does it mean? Determination of dependency arcs in the syntactic tree, the immediate domination relation over the tokens. So for each token, we want to see what the parent is, what it depends on. Okay, and then when we do that, to label the selected arcs with the appropriate dependency relations. So this is not a novel approach, this is very popular approach. So we use this. In our implementation, both the transformer model and the head selection model are directly connected. The head selection model is integrated as an additional layer over the last layer of the transformer model, because we believe that it should collect as much information as possible through the way and then to take this decision about the heads. The head selection model is similar to any other token classification model, except that the number of classes is dynamic. So it varies depending on information from the data. Yeah, maybe it's not very well visible, but it shows the typical architecture. And in the middle, actually, we manipulate this. We put this shell information before we go up and take this decision of head selection. That is basically this picture. Okay. So we worked with two universal dependency tree banks. The one is ours, BTP Bulgarian tree bank, and also the GUM English tree bank. There are several English tree banks, but as I said, we use the one that is comparable as size to ours. Okay, so we selected our tree bank because we wanted to do some experiments on Bulgarian, of course. And we could use our chunk grammars and also some preliminary multi-word expression information. And as I said, it is basically the information that we have in the tree bank, and it is basically fixed multi-word expressions. Okay. For English, we just wanted to show that this algorithm also, this model also works for another language. And in cases, in Bulgarian and English, we show that even when we select arbitrary sure args, not specifically defined, even then the results are better. I mean, they improve. And we can imagine if we just have really a lot of sure links beforehand, how it would go. For Bulgarian, we show that it works. For English, we just show by the arbitrary generated args that it really improves the results. Okay, so here you can see the experimental settings, pre-trained model with what parameters and encoders and so on. How much the Bulgarian tokens are. So the pre-training dataset consists of mainly web data, literature, administrative and scientific documents, and also Wikipedia articles. And you can see how many epochs and so on. Yeah, I will not read them, but they are there. Okay, for results on Bulgaria data. So in italic, we can see the baseline, which is the best model for a baseline, and then the best model is prompted with 40 links, sure links from shallow syntax. And here we have two numbers. On the left in bold, we have this model with the predefined args from our chunk grammars and also from multi-word expressions, because we have them for Bulgarian from the tree bank. It really improves the result, not as much as on the right, the underlined numbers. This scenario on the right is not very realistic. It is very nice as a result, but it's not realistic because it is the arbitrary, using the arbitrary links from the tree bank. And the problem here is that we don't control them and we don't know what can happen and how it goes and so on. So it's really just to show that even with arbitrary knowledge inserted into the model, it becomes better. But we aim at improving the one with controlled links from the lexicons and from the tree bank, that we really know what the knowledge, the linguistic knowledge is. Okay, so our intuition is that this reasoning happens in the last layers of the encoder. I already mentioned that, just before the head selection layer. since the head selection layer predicts the head of each word independently. Thus, no information sharing can happen there. So that's why we get this information from outside sources in the middle layer before we go to the head selection layer. That is the idea. But of course, it's just an intuition, right? So it could get other results from other languages and experiments. Okay, so from our point of view, from these experiments, the lessons are this. Using an arbitrary predefined subset args as prompts is sufficient to train the model to recognize the prompts and produce good results. This one is just not there. Anyway, the ability to train with an arbitrary subset of prompts is important, especially when for a language we don't have resources. The fine-tuning training is done for these 10 epochs with a learning rate, with linear decay, and so on and so on. So there could be also other settings. But we think that it is promising direction to go and to see what happens next, maybe to have also experiments with more languages. Just to show the results for English. As I said, here we don't use predefined shallow args, but arbitrary args from the tree band, and even with 20 such predefined arbitrary args, the results are much better than the baseline. Just we show this. And of course, we measure the unlabeled and also labeled ones. Okay, but of course, we did also, I'm very big fan of manual evaluation, very big fan, so nothing goes ahead without this. We have performed some on the baseline model and the best model, prompted 40 for Bulgarian. And of course, we try to see the baseline, the errors in the baseline, and the errors in the best model. Okay, the baseline makes errors in, for example, wrong head direction. It should be in one way of direction, but it did it in the other way. I will not go into details because it's very specific to universal dependencies, but it's there. Wrong head selection, we would expect some to be the head because it should learn it, but then it selects the other one. And especially in such constructions like in Bulgarian, like glass of water, чаша вода, of course, both of them are can be licensed as heads. But in our model, the first one should be the head, and the model selected the second one. I mean, otherwise both could be a good solution. Wrong head assignment. Yeah. Then wrong root assignment, and of course, wrong PP attachment. So the usual things that would make problem also for a parser. What we see here, where the best model makes errors, very often the types of errors are the same, of course. Wrong head direction is the same, wrong head assignment is the same. But here we also have this wrong non-PP attachment very often, which is interesting for the best model to do that. The adverbials, the problem with adverbials. Just to summarize, as it can be seen from the observations above, both models generally make identical types of errors. At the same time, it seems that the best one has more attachment-related issues, while the baseline more head-related issues. Of course, they can cross, but this is just what we have from the data up to now. Okay, so our idea was to show that The extension of the transformer architecture with some knowledge, even shallow syntactic knowledge, already improves the model. And it is due to the fact that the head selection model is improved. But it is also shows, this is the downside here that we should work on, it is not an extension of the baseline model, the new one. It's not just an extension, but it seems that they cover different search spaces. So at some point, we would like to have a model that extends over the previous one, but not just to have these discrepancies. Okay, and I'm just summing up. Envisage improvement, but not only this. Through the improvement of the prompt attention layer by including more linguistic information and see, of course, at which point it helps and at which point maybe it will decrease, and I don't know. It could be a grammatical feature, shallow semantic information, some ontological information maybe for named entities, and so on. But the important thing here is that it should be reliable. I mean, just to put knowledge that we know it's reliable. Through the extension of the tree bank with new sentences, selected with the help of some active learning procedure, because of course the coverage of some phenomena might not be enough. Through the improvement of the shallow grammar and the coverage of multi-word expressions, lexicon, but really the lexicon with idiomatic expressions and all these problems with the word order and everything that might cause problems as well. And of course, the related algorithms for better prediction and consequent recognition in text. So, really, last of the last, we extended the standard transformer block architecture with a new prompt attention layer, which incorporates some knowledge. As I said, it's modest, not very full-fledged, but still, from external knowledge sources. In this way, it is internally modified to produce a better dependency passing model. And we would like to use deeper syntactic knowledge, improved shallow syntactic knowledge, and also semantic one. And also not only during the fine-tuning stage, but the pre-training stage. Okay, so I think I managed to share with you what I had in mind with this. Thank you very much for your attention. Maybe we have just 1 or 2 minutes. Yeah, just if there are some questions. Yeah, please. Okay.
So, everyone try using multi-agentic frameworks based on large language models. You can use it not only on foundation models like general pre-trained transformer, but you can use it on almost any kind of language model. Why am I asking? It's kind of a new thing in the large language models in the last 8-9 months. And it's very promising. It shows very good results in general maths, for example, 8K set, and it shows huge improvements even with models like GPT 3.5, which is coursework and 4. Have you considered using multi-agentic pictures?
Thank you very much. It's a very good question. So at the moment, we don't aim at using GPT. I mean, these dialogue-oriented models, right? Our purpose was to train a BERT model for Bulgarian, and doing this, we decided what we could use to improve it. But if you say that we could also incorporate this one, we of course we could try, and I would like to thank you for this. Just initially, we were not aiming at this, multi-agent.
Or work group where you have a different personalities, like for example, list expert, tech expert, and manager. And with many iterations, they're kind of refining, they're having a task and they need to solve it, and in many iterations they're solving it. So this is the basics.
Yeah, thank you. I think that could be useful, of course, and we should consider that. I can say I didn't know myself that there is this because we didn't aim at GPT using this line of language models, but I see a potential in this. So thank you so much. Thank you. Okay. If no other questions, I'm a very nice lecturer. Thank you very much for listening to me. And after the lunch break, please come for the really exciting course on multi-word expressions. Okay, thank you.
Yeah, right, what's your favorite language to learn?
That's okay. It's why they are not better than
PowerPoint.
another all is good.
Yeah.
Yeah, that's
Okay, I think it's time to start and welcome to the afternoon session. I'd like first to introduce to you the lecturers. They are both. And as you'll notice, maybe this course will have face-to-face part, which is today, but also an online part on the 11th, right? And you can check the details in the program later, but they will tell you as well. So we have a mixed international, nice international team. And first I will introduce the guest, Verginica Mititelu. And she's a linguist. Um, and she's a senior researcher at the Romanian Academy in the Institute for Artificial Intelligence. And what we can also see in her CV, she had her master and PhD degrees at the University of Bucharest. But for years now, she has been working in the area of language resources, and she's also interested in working on these resources for Romanian, because we should do work for Bulgarian like our colleagues and Romanian, not only English, but also to She has experience in standardization of the resources that were developed and also linking of resources, linked open data, which is also a very modern trend and very necessary trend, together with large language models. So she has been part of many international projects, and maybe I can share this part a bit with the next speaker with her. The Balkanet, about the Balkan work nets, Clarin infrastructure, MetaNet for you, Accurat, and so on. All these projects are related to language technologies for many languages, not only one. Okay, so I know Verginica also from some time now, and we work together as well as Ivelina later. I will introduce her in cost action parsing, which was on parsing multi-word expressions. It seems very small problem, but believe me, it is really big problem in parsing and language processing. And it is very fortunate thing that nowadays we have this Unidive cost action, and it combines these output expressions and how they are processed in the framework of universal dependencies. But also they are interested in the interface between lexicon and grammar, and Verginica leads this package working group. The lexicon corpus interface. So this was the one introduction, and now I go to the other one. It is about Ivelina Stoyanova, who has been working at the Department of Computational Linguistics at the Institute for Bulgarian Language for some years now. And she has, it's a very good thing, she has degrees from different institutions. One is the Bulgarian Philology, Sofia University, where we met actually. Then she did a bachelor's degree in computer science and mathematics. She has this degree from the University of Bath, UK. And she obtained her PhD degree from the Institute for Bulgarian Language in 2012. And we should mention that her thesis was focused on the multi-word expression recognition and tagging of Bulgarian. And I think it was maybe the first survey and the first work on this. And it's a reference work. I mean, whoever works on that should cite it. She also works actively on many projects. I mentioned most of them. I should also mention in the end that she's also very active member of Unidive action, cost action now, and she was very active also in the parsing cost action. And again, she was the responsible person for the Bulgarian part that was annotated with multi-word expressions. They first did the verbal ones, but now they had for the nominal and other others. Okay, so now you see that they are very, very into the topic they will present to you. And maybe it's just time to give the floor. Okay. Thank you very much, Petya, for the nice introduction. So, as Petya already mentioned, this is a longer tutorial. We have 3 sessions today and 3 more on the 11th of September, and they will be online. Today, in the first session, we are going to cover about multi-word expressions, their definition, examples, some examples, characteristics, lexical, I'll present some lexical resources. Then in the second session, Eva will cover state-of-the-art of multi-word expressions identification in text. And in the last session, I will sort of prepare what we are going to do on Wednesday. Namely, we are going to look at the way in which we should annotate verbal multi-word expressions. We'll focus only on this now.
So I hope until Wednesday morning you won't forget this, but anyway, we'll probably resume some of the most important aspects on Wednesday morning. Okay, so this is the plan for today. I think we'll manage to cover everything. We'll start with the definition of multi-word expressions, of course, which, as Petya mentioned in the previous tutorial, is, well, with natural language, actually, the definition of any phenomenon is not easy. And multi-word expressions are no exception to this. They were defined by Nicoletta Calzolari in 2002 as a sequence of words that act as a single unit at some level of linguistic analysis. The focus is on this phrase, a single unit. So, although they are made up of several words, they should be considered as one entity, one unit of analysis. A few years later, Baldwin and Kim described or defined multi-word expressions as being lexical items that can be decomposed into multiple lexemes, and they display lexical, syntactic, semantic, pragmatic, and or statistical idiomaticity. So we see that we go a bit further from the linguistic level of analysis. We have some frequency also involved in this last part of the definition. This term of idiomaticity should be understood as markedness or deviation from some basic properties that the lexemes making up the multi-word expressions have. Now, what we should remember from these two definitions is that a multi-word expression is a combination of at least two words, and they exhibit these idiosyncrasies at various linguistic levels, plus the frequency level when we have a corpus, of course. Now, so the definition that was commonly agreed upon within the Parsim action that Petya mentioned before. Should I explain what Parsim is? Well, this was cost action. These are like projects, let's say, which are funded by the European Commission under a specific track where there is money for having people gathering together and discussing problematic aspects of their work, finding solutions to different problems. So there is some money allocated to these projects, to these actions they are called, but for people to create large networks in which they try to find solutions to different current problems in the respective community. It's not development, a proper research problem, but these actions can actually help research and development projects. Parsim was such an action that they last for 4 years, and this one was during the, well, I don't know exactly the period, it ended in 2017, I think, so it started in 2013 because there were some months with which the project, the action was extended, and we already have for 2 years a new such action, which is like a follow-up of this one, but this is called Unidive. But in this action, in this new action, two communities are, actually 3 communities are brought together, the former Parsim, the universal dependencies, which is focused on offering the principles of syntactic annotations that are valid for all languages, so it targets universality, and also the community of linguists who focus on different peculiarities of various languages. I lack now the term. So there is a certain branch in linguistics that studies the peculiarities of various languages. I really cannot find the term now. But if you check the Unidive website, you'll find there. So within Parsim, this is the definition that was agreed upon by the members, and this is also taken over in the new action. So we have a combination of at least two words that exhibit idiosyncrasies at various linguistic levels. Well, even this definition is problematic because we have this notion of words, and as linguists, we know that a word is hard to define. Not only for languages that for those Asian languages that use do not use a proper alphabet like the Europeans one, but even for European languages, there are situations when a word is hard to define. That's why there is this, let's say, equivalence between a word and a lexeme. So words here should be understood as a lexeme, a basic unit of a lexicon, so a unit which can be assigned a meaning, a form. And when you process natural language, there is another term that appears that is usually used by specialists, namely the token. This is the basic unit in automatic language processing. Well, we can say that a word, yeah, in this definition should be understood as a lexeme, which is rather the same as a token. But because I didn't use there the equal sign, this means there is no one-to-one correspondence all the time. Because we have, for instance, compounds, which are treated in lexicography, for instance, as one lexeme. But these are actually in the automatic analysis multi-word tokens. And in language, we find, for instance, contractions like isn't in English, which in the automatic processing of language you should split into different words. So they will be treated as different tokens as well. Sometimes such strings of letters are not that transparent. If we look at, for instance, at that last example, which is from French, we have this O, which is actually the result of putting together a and le, so the preposition and the definite article. So again, in automatic analysis, this should also be split. This O in those two components, those two words. So you have one token, but you have one word, but actually you have two tokens there, yeah? Another problematic term in this definition is idiosyncrasies, which means a strange or unusual habit or way of behaving or feature. Again, this is not something very clear or very clearly defined or not always understood in the same way but by different specialists. So we assume this, let's say, drawbacks of the definition. And the linguistic levels that are considered are those that were also mentioned before, the lexical, morphologic, syntactic, semantic, and pragmatic level. The last one being not so well studied within these two actions and in the community in general. The most important characteristic that is considered an idiosyncrasy of multi-word expressions is the fact that they are semantically non-compositional. So in the example given there, rock music isn't really my cup of tea. We have this string, cup of tea, and when we try to understand this sentence, of course, we need to understand the meaning of the whole sentence by considering the meanings of the words making it up. However, the last three words shouldn't be understood with their meanings, but they should be treated as one unit which has a certain meaning. Yeah, so rock music isn't my favorite type of music, is the understanding. Of course, all these things were all reported or described in the literature many years ago by linguists. It's not something that automatic processing or new generations of linguists have come up with. So in the 60s, Katz and Postal wrote this, that the essential feature of an idiom, but they refer only to idioms, so you see that multi-word expressions actually cover more than idioms, is that its full meaning, and more generally the meaning of any sentence containing an idiomatic stretch, is not the compositional function of the meaning of the idiom's elementary parts. So, cup of tea has a different meaning than the components. After giving a definition to multi-word expression, the community focused on classifying them. And we have here a classification with, so the major types of multi-word expressions and also some subtypes. Of course, they because syntax and parsing was also interested in parsing. So in syntax, all these categories are syntax driven. So we have verbal multi-word expressions, nominal ones, adjectival, adverbial, prepositional, conjunctions, and so on and so forth. Because as reported in the linguistic literature, we have multi-word expressions for all parts of speech. If there are some gaps in some languages, those are exceptions, but otherwise each part of speech can display some multi-word expressions. We have classification, sub-classification, let's say, of these two major, maybe the richest classes, the verbal and nominal ones. Let's say we will adjust it further on in the presentation. We have light verb constructions here. Give a lecture. Why are they called light verbs? Light verb constructions. Well, because the meaning of this multi-word expression is not non-transparent. It's rather transparent. But the problem with the meaning here is that the verb doesn't bring much information, doesn't contribute a lot, sometimes doesn't contribute at all to the meaning of the expression. It's only the noun which contributes the semantics of the expression. Now, to give a lecture is actually to lecture. We also have this noun in English. Idioms. These are probably the most spectacular in the sense that their meaning is not compositional at all. And we have plenty of examples in all the languages. One such example here, to let the cat out of the bed, which means to reveal a secret. A phrasal verb which English abounds in, but other languages do not have such types of multi-word expressions. I think Bulgarian doesn't, just like Romanian and many other languages actually. With nominal expressions, we have compounds. Well, a problematic category maybe, because some linguists wouldn't treat them as multi-word expressions. There are also different norms in writing them as one word, or using some hyphens, or using even a blank there. So they are problematic in this respect. We have terms which also are problematic because people tend to analyze, or linguists would say this belongs to terminology, not to lexicography. Then we also have idiomatic multi-word expressions like piece of cake. This is probably the canonical example of nominal multi-word expressions. And there are examples of other parts of speech, of multi-word expressions of other parts of speech. Okay. Now, regarding their characteristics, we are going to look at various linguistic levels and mention what is peculiar about these multi-word expressions at these levels. But the lexical one, of course, not all expressions have the same characteristics. So some of them are displayed by some multi-word expressions, others are displayed by other multi-word expressions. But remember that the general characteristic is that they are semantically non-compositional. For instance, what could happen at the lexical level is that one of the components of the multi-word expression occurs only within that expression in the language. We cannot use it outside that string of words. In English, for instance, well, we have ad hoc, which is not made up of English words, of course, and they do not occur in English outside this expression or outside other expressions, because sometimes there are components that occur only in several expressions, but not alone in the language as other words do. Maybe more English specific example is go astray, made up of English words, but astray is not used outside without go, I mean. Yeah. So whenever we find such a string, we consider it a multi-word expression because we have these cranberry words, they are called, so they do not occur, we do not use them in language outside these expressions. Yeah. And this term, cranberry words, is rather new in the literature. It happened to me once when I submitted a paper this year to a major conference, actually, to have a review in which the reviewer contested the usage of this term, saying that nobody used it, but actually in the community we do use it. Maybe it's not spread enough, but it will probably become if we continue using it in our papers and when we disseminate our work. Another lexical characteristic of multi-word expression is the lack of flexibility of one or of more components in the expression. We have here two examples, hot dog and hot soup. Hot dog is a multi-word expression, whereas hot soup is a regular combination of words in the language. Well, if we try to replace the adjective hot with other words, synonyms or not, they could be antonyms, words that can occur in that syntactic position. So other adjectives from the same, let's say, semantic field. For instance, cold. You can safely say cold soup, but you cannot say a cold dog to refer to this or you cannot replace the noun in the string. Hot husky, for instance, you cannot say this, although husky is a hyponym of dog. But you can say hot pizza. Well, maybe I should have said there hot tripe soup, as it was mentioned at lunch today, or hot chicken soup, or something like this. Yeah. So I replace. I mean, it's not really parallel the examples because husky would be a hyponym, let's say, of dog, whereas pizza is not a hyponym of soup. Now, at the morphological level, we also have this lack of flexibility or inflexibility of some components. Again, we have this time I don't have one example of a multi-word expression and another of a regular combination of words. This time both are multi-word expressions, so both goat, bananas, and kick the bucket are multi-word expressions. And in both of them, you can see that the noun cannot be used in a different number, with a different number than we regularly use this expression. So you cannot say about someone that he or she goes banana. Only bananas, yeah? Go crazy about, I don't know, hearing some news or something. People kick the buckets, they never kick the buckets when we mean they pass away, yeah? Sometimes these multi-word expressions preserve older forms of words. For instance, in Romanian, we have this expression, a pune pe roate, which means to make something work. And in this expression, we use this old plural form of the noun will, roată, which is roate, because the plural form of roată today is roți. A car has several roți, several forms. Okay, so they preserve archaic forms of words. At the syntactic level, there are several characteristics that they display. We have sometimes strange combinations of words. For instance, in the first example, where we have a coordination, we have a preposition and an adjective that are coordinated. And we know that in language, we coordinate elements of the same type. Now we coordinate nouns, we coordinate verbs, but not different parts of speech. Or if we coordinate different parts of speech at the syntactic level, they behave the same. But here, this is strange for the characteristics of the language. That's why this is a multi-word expression considered. This combination functions as an adverb. Then there are sometimes contrary to the rules of the syntactic rules of the language, some phenomena are not allowed. For instance, in this structure, in addition to, we have a noun, but it can never get the definite article, as other nouns in such syntactic combination do. For instance, if we compare in addition to it in the address to the nation of a president, let's say, yeah. Well, there we need or in an address to the nation, yeah. So we have either the definite or the indefinite or other determiners, yeah, can occur there. But here in this expression, in addition to, we cannot have either on, the, or other determiners. In the next example, in kick the bucket, we see that the bucket, even if it's a noun, it cannot be modified by an adjective. So someone cannot kick the rusty bucket when we mean they die, yeah, or another kind of bucket. Expressions are used with a certain word order most of the times. There are exceptions, of course, but the word order should be considered rather fixed whenever they are short. For instance, we say drink and drive, but not drive and drink. There are some rhyming problems also, so stylistics also study this phenomenon. And some syntactic transformations that are allowed in language are blocked actually with multi-word expressions. So kick is a transitive verb, so we have a subject and a direct object. But in this construction, we cannot pacify the direct object. Although if we use this sequence of words in the proper meaning, I kick the bucket, yeah, meaning that I really hit it with my leg, I can say the bucket was kicked by me. But when I mean someone kicked the bucket, someone died, I cannot pacify. I cannot say the bucket was kicked by X, meaning that he died. The semantic level, we mentioned non-compositionality, which is, of course, not easy. because as mentioned before with light verb constructions, this is a matter of scale. So some expressions are totally opaque from the words they contain. You cannot tell what they mean. Others are rather close to the meaning of the words making them up. Here in the example, I have a decreasing, let's say, level of compositionality, of non-compositionality, with cost an arm and a leg being opaque and phone book being rather transparent. So you could say what a phone book is as a person. I imagine nobody imagines it's a book full of phones, yeah? So it's a book with phone numbers. Whereas cost an arm and a leg, someone who hadn't met it before couldn't. Well, the context helps us, of course, but if you read it outside the context, you cannot say what it means, probably. Okay. Well, at the pragmatic level, which I told you is not so widely, well, pragmatics is not that widely studied in NLP because of the difficulties it raises. But still, what problems are there? So there is an association where as a rule, we use some expressions in certain circumstances. So there is this association between multi-word expressions and the communication circumstances. For instance, when we greet someone, depending on the moment of the day, we use a certain greeting, or depending on the moment, if we meet or if we leave someone. So at the beginning or at the end of the meeting. And there's one more example linked to, or depending on traveling. So when trains or ships are about to start the journey, you can hear this all aboard message. Why are linguists interested in studying multi-word expressions? Well, there are a lot of reasons besides these linguistic challenges that I showed. Besides the fact that they preserve older forms of the language, they will also preserve some history, we could say. For instance, English is not my mother tongue, and even for the multi-word expressions in my mother tongue, I'm not always aware of their origin. You know that there are researchers who invest, or at least in Romania, I know someone who spent all his life working on this to find out the origins of of many, not some, idioms. For instance, for spill the beans, they say that it has to do with ancient Greek elections, in which they used some beans and which they put in some recipients, and to spill those recipients, or the beans in those recipients, meant to reveal who was the winner actually. So to spill the beans means to reveal a secret, something that was hidden before. So it was secret voting, yeah. And spilling those herbs probably meant revealing who the winner of the elections was. Sometimes, I think we do it every day probably, we prefer using these expressions because they are more relevant when we speak, when we want to put through a certain message. It saves time to give a long explanation. So Proverbs, for instance, easier said than done here. So instead of explaining someone in a lot of words, you use the proverb and they should understand you. Sometimes these idioms usually are associated with a certain connotation. I still have some time, right? Yes, okay. So they are associated with a connotation, and you can see there that a barrel of laughs in English has a positive connotation. If I say about someone that Maya, for instance, was a barrel of laughs, this means that the long drive we had together was quite quick because we didn't get bored. Whereas, for instance, fed up, I'm really fed up, has a negative connotation. Well, they are also problematic, these multi-word expressions for speakers. And what I noticed as a mother of a teenager, I could say that there is also a difference between generations. Because younger generations are not so much exposed to this multi-word, to idioms, to proverbs, or maybe they are creating new ones. So they are not able to understand those that they encounter when they read a text, when someone older talks to them. They look strange and they require some explanation. So they are not easy even for native speakers of different generations. For learners of a language, they are of course problematic, as you all know here. And besides this, there is also this linguistic creativity which is involved, and speakers of a language always modify them. So although we say that some modifications of the nouns are blocked, well, creative speakers do this, and this is for sometimes these are plays upon words, so for fun, jokes, and so on and so forth, but they happen in language, and probably usually in our free time, but also in newspapers. The journalistic language, I think, it depends on the topic, maybe, but they abandon such modifications of multi-word expressions. They are, as Ivan will show in the next session, they are problematic for processing, for automatic processing of language, and also for translation. Well, I showed some examples previously that tell us that even if we have at the syntactic level the same structure, we can work with two different expressions, two different types of structures, let's say, in the language. So when the syntax of an expression is that of a regular construction, as you can see here, we have to pay attention to the other aspects to distinguish between regular constructions and multi-word expressions. Here there are examples of different syntactic structures for which in the language we can only a few, this is not a comprehensive list of syntactic structures that are shared by regular constructions and multi-word expressions. But the phenomenon exists in the language and we should pay attention to it. Well, besides the, let's say, proper characteristics, that there are other characteristics that become visible when we talk about multi-word expressions in context. So not as mere lists of expressions, because when we use them, they tend, for instance, to be discontinuous sometimes, as in the first example. So bear in mind is one expression, but in between the verb and the prepositional phrase, there is a lot of linguistic material that appears. But we still must be able automatically to retrieve these components of the multi-word expression and to recognize them. We have the interleaving phenomenon, to take the fact that I gave up into account. So we have give up one expression inside another one to take something into account. Yeah. So we have this continuity too. Take into account are discontinuous, but in between them, we also have another multi-word expression. Multi-word tokens were mentioned at the beginning. I will skip this. And also we have flexibility on the morphological, syntactic, or lexical level. For instance, in English, we say he broke my fall, but we cannot say both of my falls were hard to. Well, if we say this, it has proper meaning. No, so not a non-compositional one, a compositional one. Well, with respect to collocations, I would say a few words. In general, when dealing with multi-word expressions, the community, let's say, do not have the same view on all phenomena. And maybe the most visible one is this distinction between multi-word expressions and collocations, which with different scientists can be treated differently. So either, as you can see in the first picture here, yeah, multi-word expressions are considered one class, one subtype, let's say, of collocations, or vice versa, where collocations are one subtype of multi-word expressions, or they all partially overlap, or they are totally distinct entities in the language. So different opinions. I will briefly go through a few lexical resources containing multi-word expressions. So these are electronic descriptions of a language in which words, lexemes are described. And we know from our, let's say, lexicography, each national lexicography, that there are dictionaries of multi-word expressions, and they have been created for decades, I would say. But the focus so far was on their meaning. So there was a list of multi-word expressions which are explained. Their meaning is explained, sometimes even with a long history of their origin, evolution, and so on. But this was the trend, let's say, so far. But nowadays, when we talk about multi-word expression lexicons, we tend to include information at various linguistic levels. They sometimes appear in a valence dictionary. So for multi-word expression, just like for normal words, verse, for instance, you also mention what valences, syntactic valences they can take. But we can also have some dedicated resources. And here the method of creation differs from one team to another, from one language to another. It depends on the purpose the respective lexicon is created for. Sometimes they cover several languages, not only one. Sometimes there are lexicons in which each expression is described at various linguistic levels individually. There are others, especially a Dutch lexicon, in which there are classes syntactically created, or classes relying on the syntactic structure of multi-word expression. So there are classes which share some characteristics, and each expression is assigned to a certain class. And usually, because this is a lexicon, exceptions are rather registered than rules, because we say that rules are described by the grammar of the language, and the lexicon should contain only the exceptions to these rules. These are the levels of linguistic descriptions. They were mentioned. Most of them were mentioned previously. What's new here is probably the derivational level, part of morphology, but still morphology, derivation and inflection. I talked only about inflection previously. Contextual aspects. There are sometimes links between the lexicon and the corpus, so you can see the expression in action, so to say. So you can see how it occurs, how it is used by speakers. And sometimes they are also assigned some register, so you can figure out if that expression is preferred in a certain style, it has a certain connotation, and so on and so forth. These are a few examples, probably of the, except for the last, well, Lemur, created by a Czech team, again, Czech, Prague, as Petya mentioned before. So this is a very large lexicon of multi-word expressions for Czech. For Dutch, we have Ducame, which is the follow-up, I'd say, of Duelme, a previous version. This is also enlarged, of course. Edian, which was developed for Greek. And we can also say that as a one result, because we have more, of the collaboration between the Bulgarian and the Romanian team, we also have a multi-word expression lexicon, which is quite rich in the sense that there are a lot of linguistic levels included, but not rich as the number of expressions is within the dictionary is concerned, but it's only the beginning. This is an example from our dictionary of two expressions. Well, actually, there are two sets of expressions because what our dictionary has and no other such resource reported so far has is the fact that we use our word nets, which are aligned to each other via the English word net. And this makes the retrieval of semantically equivalent expressions in the two languages quite easy. You can see here two synonyms, so two expressions in Bulgarian that have the same meaning, and three semantically equivalent ones in Romanian. And then in the table you can see their descriptions at various linguistic levels. It's not a comprehensive descriptions, as I previously said. We follow that trend that only idiosyncrasies are marked in the dictionary, not those elements that follow the language rules. So that are not problematic actually. Yeah, so the well-behaved elements are left out. These are further materials that could be studied, and also this course is based on the last course available there. And some references, and I think we are done with the first session.
Okay, let's start with the second session of our tutorial. I will talk a little bit about the process of multi-word expression identification, as Verginica already mentioned, and Petya Osenova before her, that we share our work within the Parsim cost action, and also its sort of continuation, the Unidive cost action. And what we were doing there, focusing on multi-word expression and their treatment, the development of lexical resources, and how these were applied for the purposes of multi-word expression identification. So I won't be talking in general, but focusing mostly on what we have done. So what are the challenges? Why do we still work on multi-word expressions? Why is it such a big deal, and why is it so difficult to deal with them? What was said before, the challenge is basically in their idiosyncratic nature. So they behave not as just the usual combination of two or more words, but they behave in a different way. And idiomaticity can be expressed at different levels: lexical, morphosyntactic, syntactic, semantic, and so on. And at each of these levels, there are a number of challenges that we need to address, both in developing lexical resources, but also in corpus annotation, and also when we are developing natural language processing applications. So how do we deal with multi-word expressions, and how do we address all these levels of idiomaticity where we see them? So from a practical point of view, just focusing on the practical point, as was already discussed, they may appear within with a different word order. So for verbal multi-word expression, the verb can be the first part or can appear at the end. The components may not be adjacent, so there may be other words, other parts of the sentence that appear between the parts of the multi-word expression, and also even more complicated, there may be some modifiers that appear to one of the words of the multi-word expressions. For example, we can make a decision, or we can make a difficult decision, or we can even make a very difficult decision, and so on. So we can modify components of the multi-word expression. And how far can we get? I mean, how far can we get with this process, and what is then the multi-word expression? So are these three different multi-word expressions, or is it just one? And how do we represent this in a lexical resource? Do we allow certain modifiers? Do we allow certain variations within the multi-word expression? Or do we consider them different multi-word expressions? And how do we treat them when we start processing the text? How do we deal with them? Also, as again was already mentioned, the phenomenon of multi-word expression covers a wide range of different types and degrees of idiomaticity. So, okay, some of them may be completely opaque, while some of them may be transparent to a certain degree. So, from which point do we consider an expression to be a multi-word expression rather than just a pre-combination of words? The example with phone book, is it a multi-word expression? Because, okay, it contains phone numbers, but it is not fully described what it contains. So for some people, it may be completely clear, but in a few years, maybe there won't be, they won't look like a book. So then, is it still transparent as an expression, or is it already turning into a multi-word expression? Okay, another example, maybe if we consider the example of polar bear. So is it transparent? Or because, okay, we can say, okay, this is a bear which lives on the North Pole, but it doesn't really live on the North Pole itself. Its habitat is much larger, and it is near the North Pole, but it's not exactly the North Pole. So to what degree is it transparent to every speaker of the language? Or, for example, in Bulgarian, the expression is white bear. So the equivalent of polar bear is white bear. So is it transparent because it's white? While it turns out that its fur is not actually white, it's more transparent, so it appears to be white. So is it a free combination of words? Because everyone can understand that it is a bear which looks white, okay, but it's also the term that names the species. So in this case, it's not completely transparent. So to what degree is this transparency actually transparent or not? Also, another challenge is in terms of the morphologically rich, for morphologically rich language, where there are a lot of different forms. Some of them, for example, if we consider the head of the expression, which is maybe one of the most important components, then, for example, in Bulgarian and other morphologically rich language, there are a lot of different forms. So do we consider all of them to be to represent the multi-word expression, or do we just take the full meaning words out of these forms? How do we deal with them? So here I'm mostly raising questions. I'm not giving any answers because they are. This is what we are trying to do. Basically, we pose all these questions within these cost actions, and we're trying to find some answers for some of them, and for most of them, we're still not not finding these answers. Also, problematic are expressions which can appear both as a multi-word expression or have a literal meaning, as one of the examples was a piece of cake. So it can be a literal piece of cake, or it can be like in the context where it's something is a piece of cake, an activity is a piece of cake, then it is in a multi-word. It is a multi-word expression. I already mentioned that there might be a degree of variability within the multi-word expression. Some components might be able to take modifiers. Also, multi-word expressions, they are language dependent. So they're specific to a particular language, to a particular culture. In our work on Bulgarian and Romanian, we discovered there are a lot of multi-word expressions that are common. I mean, that are formed in the same way in Bulgarian as well as in Romania, which is explained with the closeness of the communities and the cultures as well. But these are to a high degree language dependent. So they are a challenge for foreign language learners to understand them, to acquire them, and sometimes even for younger generations, they lose the sense of the metaphor that brought the multi-word expression meaning. So from partly transparent, it can turn into completely opaque for people, even for people who are native speakers. And especially what we in the context of computational linguistics, the biggest challenge is for the computers to understand them. First of all, for the computers to identify them, to see which they are in a text, and then to interpret them, to make sense of them in the sense that to somehow decide what their semantics is, and after that to, like for example, translate them. So for machine translation, multi-word expressions are still a big challenge, even with large language models and so on, as we will see in a bit. And also another challenge that was the focus of these cost actions that brought together people from different countries, from different linguistic traditions, was the challenge that multi-word expressions were treated differently in different linguistic traditions. So the idea behind the cost actions in general, and these ones in particular, was to see how different linguists treated them, and to find some ways to bring together knowledge from different perspectives, and to find maybe better solutions for multi-word expressions. And so one of the goals of the Pars team action was actually to just not develop just the theoretical side of things, the discussion of the idiomatic nature of multi-word expressions and their types of idiomaticity, but also to address in a uniform way the way they are treated, so that to facilitate the computational processing, things like machine translation and so on. So here I just listed a few approaches that generally can be found in the literature that deal with multi-word expression, and mostly from a computational point of view. And these approaches, some of them, and that was more the focus of like 20 years ago, where they were addressed, their treatment was addressed with resource-light approaches. So to say, applying like statistical measures, measures that measure the association between words in like big row corpora data and so on. So on the other side, mostly developed by people with background in linguistics, were resource-based approaches. So people who are saying, okay, we can't deal with them without the lexicons. We need to develop large lexica of multi-word expression, describe them from all possible perspectives, and that's how we deal with them. And then also machine learning, distributional methods, which basically compare the distribution of the multi-word expression and separately the distribution of its components with the purpose to identify where they behave differently and to identify cases of multi-word expressions. But still identifying them doesn't give doesn't provide their meaning. What their meaning is. We can identify that something doesn't behave regularly, but we can't say what its meaning is. So even with these vector-based approaches, word embeddings, and so on, it is difficult to properly, fully, solve the problems of multi-word expressions. I think that we already saw, like with statistical methods and multi-word expressions versus collocations. So the collocation side of multi-word expression is just one side of the things. And as we saw, one side of the idiomaticity was the statistical correlation between the words that appear together as a multi-word expression. But that's just one side of it. And a lot of researchers actually say, okay, let's distinguish between collocations and multi-word expression and focus on those collocations that have also another level of idiomaticity. For example, the semantic level, which is basically causing a problem, because even like for a basic collocation, like for example, order a pizza or order a takeaway, it's not a problem to translate it literally. But if we have multi-word expression, then we need to treat it as a whole and translate it in a completely different way. So just a few words about like large language models and the place of multi-word expressions within them. I just briefly mentioned that basically, although the big rise of large language models and multi-word expressions still stay a problem for them, and also what the most recent sort of trends within these is to basically also involve linguistic information in building the models, in treating these specific linguistic phenomena, which are not, they are not very frequent, they are not very well behaved. So to treat them with a focus on the linguistic information that they provide. And so these are two sources that basically focus on what can be done better for multi-word expressions in training and in using large language models. And a few years ago, there was a paper, a position paper, which came from people who are heavily involved in the Parsim action, who basically, the title of the paper states the position that without lexicons, multi-word expression identification will never fly, which basically what their feeling was that even in the context of big data and large models and so on, without the lexical resources providing linguistic description of multi-word expressions, we won't be able to solve that problem, at least, and especially for low resource languages. So maybe to some extent, for example, English or German, maybe, but not for low resource languages. And also they insist on lexical resources which are developed together with annotated corpora with multi-word expressions, so that to work towards solving the problem of their treatment. But then we reach the point where we need to develop these resources, to develop these lexical resources, and to develop these annotated corpora with multiple expressions. And we reach the point where it requires a lot of work. It is a very time-consuming and very expensive task to develop resources, and also how big corpora, how big lexical resources, how many multi-word expressions. And also it appears that multi-word expressions, they are not a fixed quantity in the language. All the time, some of them are not used anymore. Some new multi-word expressions appear. So it is a constant race against time to develop these resources. And also the annotation of corpora, we took part with my colleagues in Parsim, and we annotated the corpus there, and it took a lot of time. And not only that, but it took a lot of time a lot of effort to decide on the annotation procedures and to agree on categories of multi-word expressions and so on. So this is what Verginica will talk about in the next session, about these guidelines that were developed within Parsim to ensure that these corpora that are annotated there, that come from this effort, are annotated in a consistent way and uniformly across different languages. And then, on the other hand, we can have resources of discovered multi-word expressions. So, for example, if we work with corpora, we can identify their multi-word expressions, although not knowing their meaning or although missing information about them. We can extract from corpora and use them to train applications and to extract information, description from them to use for further development in the field. So that's basically another approach that we can address the need for more resources, like working with both corpora and lexical resources and bringing them together so that we can develop more and more resources. And just a few words about efficiency, and what in recent years started to be a topic of research and started to be a topic of discussion, because with these large models, and also before that with big data and so on, it brought the question of how reasonable is that? I mean, because some of the large models, they require a lot of computational power, a lot of resources to compile and to develop and so on. And these large artificial intelligence models and so on require a lot of resources. So some authors already raised the question to sort of discuss, at least in the community, to discuss the reasoning about the interaction of different resources while taking the different phases of the life cycle of a model or of an application into account. So to decide how efficient a model is based on how useful it is, rather than just develop larger and larger and larger models. And in some papers also, it's discussed, the efficiency is discussed as, the state of art is described as Pareto state of art. Because what the Pareto principle is that basically 20% of the resources will cover 80% of the data. So do we need 80% of the resources that cover just 20% of the data? So how, I mean, after this, we develop this 20% and we cover 80%. Do we need more, and how much more until we cover 100%? But at some point it becomes inefficient. So at what point do we stop with that process? But on the other hand, especially in the context of language. So do we leave less frequent language phenomena out of the research that we do? I mean, do we still focus on them? And especially with multi-word expressions, some of them are rare. So do we still deal with them, or do we just skip them and, you know, just leave them out of our researches and of what we are focused on? So also that's a question without an answer. Just the question that we need to ask ourselves when we develop language resources: how far are we willing to get? And so a few words in the context of this, a few words about the parsing corpora and the shared tasks. So the parsing corpora were developed on various languages, the languages that had teams who were willing to put effort into annotating corpora within the action. And the main idea was to cover as many languages as possible. And also, not only that, but to cover them in a uniform way, so that develop resources that are basically, that can be used cross-linguistically, that can be used for multilingual NLP tasks. And at the beginning, the first corpus that was developed in 2017 included 18 languages. Then they were gradually increased. In 2020, there were just 14 because, as I mentioned, they were developed so that these data that were annotated were provided as training and testing data for a shared task each time. And in 2020, the shared task was just focusing on 14 languages. But these are basically the corpora, the initial 18 corpora for 18 languages were enlarged and included more different texts and so on, more multi-word expressions as well. But basically, and they were used in these shared tasks. You can basically, I think I included some links that you can go and see the results of these shared tasks and which systems performed better and so on. Some of the systems focus on one language, some of the systems focus on multiple languages, and you can compare the results. Also, there were like closed and open tracks in the shared tasks, and like the closed using just the training data that were provided, and others that use additional resources, additional methods, and so on. So a link to the corpora, and because these corpora needed to be annotated in a uniform way, parsing teams focused on developing parsing guidelines for annotating multi-word expressions, as Vergi will focus on those in a minute. But I just wanted to mention that their goal was to like offer a unified approach for annotation. So basically, they focused on the big picture in the sense that at the end, there were like a few major categories of multi-word expressions, for example, idioms, light word constructions, and a few others. And they focused on the major categories of multi-word expression rather than like which are basically valid for most of the languages, rather than focusing on language-specific categories. But then some teams worked on their language-specific categories of multi-word expressions as well, so that their effort is not just focused on the parsing corpora, but just to have a resource that is applicable for their language. And the idea of the guidelines is to ensure that every time you apply these guidelines for a given multi-word expressions, you come up with the same category. So, of course, there were cases which are like borderline, and sometimes you can decide one or the other. For that purpose, each language team, first of all, they had a discussion, and second of all, their inter-annotator agreement was calculated for each team to see whether there is a lot of variation within a language or people generally agree on the procedure in the guidelines. So the guidelines themselves are very useful resource, and not only because they give like the tests that you apply step by step to come up with a category with whether an expression is multi-word expression, and to come up with its category of multi-word expression, but also it contains a lot of examples for all these languages. So Bulgarian is somewhere in the middle, Romanian is one of the top with most number of examples, and so on. So you can go through the guidelines and see the tests applied for a particular language and see, see how these rules are implemented. We still have few minutes. Just to mention that I just wanted to mention the two winners of the most recent shared task. Not most recent, I don't know if there was one. No, okay, yeah, in 2020. So one of the winners, so these two systems are the winners. One of the winners was scene to scene, which was in the closed track, and the other MTLB struct was in the open track. So some information about each of these systems. And they basically performed quite well, but they also included some morphosyntactic and some syntactic information, used some morphosyntactic and some syntactic information in order to identify, to improve the results of the multi-word expression identification. And here we're talking about the verbal multi-word expression identification. So just as a summary, the goals of Parsim and its extension was the development of guidelines, and also now the guidelines of verbal multi-word expressions, and now within the unit of cost action, a group of people are working on the nominal multi-word expression classifications as well. And also people are looking to cover other types of multi-word expressions that have not been covered so far, to improve cross-lingual analysis and so on. And so the questions that I raised earlier on in the presentation, how do we represent and how do we treat different levels of idiomaticity in corpus annotation, in lexical resources, in representing multi-word expressions in lexical resources, and do we apply the same approach to all types of multi-word expressions, or we decide for certain types that we need a lexical resource to treat them, and for other types that we basically can rely on automatic methods without developing resources for them. For example, for light verb constructions, the most frequent verbs in the language can appear as de-semanticized verbs, light verbs, and combined with some nouns that have particular meaning, they can appear in light word constructions. So do we need to include all possible light word constructions in lexical resources as well, or can we rely on sort of a tailored approach towards different categories? And also consider the multi-word expression, any type of approach that we consider towards multi-word expression identification, we need to consider it also in terms of efficiency. And also some references here that you can go over. So that's from me.
Question.
Yeah.
It's all getting big questions for the audience.
Maybe at the end of the final session. Okay.
So, okay, great.
Okay.
No, okay. And that's all.
Until 50.
Well,
Until 40 past.
And also. Problems. I can see it.
So, welcome back to the last session of the day. So I will focus now on the way in which we can start annotating, and we will focus only on verbal multi-word expressions. That's because this is the only category for which we have stable guidelines. The others do exist, but we haven't tested them yet to make sure they can work smoothly for all languages involved. Well, this annotation process is a two-step one. First of all, we need to identify a string of words that is a candidate multi-word expression, and then we have to classify this according to the annotation schema that we use, and to the unified annotation guidelines. For this, we are going to use a decision tree, which is meant to help us overcome these difficult cases, ensure reproducibility, but also be consistent with ourselves throughout the annotation process, be consistent with other annotators, and be consistent among languages that are involved in this whole process of creating a corpus of annotated multi-word expressions. So the idea was to offer a universal framework for the multi-word expressions identification, considering different characteristics that languages show. Well, so considering their diversity. Well, it's a universal framework, but it allows for bringing into the foreground also elements that are specific to one language family, or to some languages. So, how do we establish that a certain string of words could be a multi-word expression? Well, the first step is actually reading the guidelines that exist, reading or being involved in their development. So we are sort of aware of what we are looking for. And then when we read a test sentence, let's say, we rely on our intuition of native speakers, because I think, with one exception, English, imagine, all annotators were native speakers, except for English, where native speakers could not be found initially. I don't know if now the English corpus is annotated by native English speakers, but there was a problem with finding them. So it's important to be a native speaker, it's important to read these guidelines, and then to start annotating. After we identify this string, we have to check it against the tests that you will see are applied sequentially. Well, the end point is when we classify this multi-word expression in one existing type, or we consider it is actually not a multi-word expression, it's a regular word combination. When we look at the string of words, we must be aware that not all elements that appear one after the other are sometimes part of the same expression. So, for instance, in the news took John by surprise, what we are going to look at is only took by surprise, because John can be replaced by other names or other nouns in general. Yeah. But in the next sentence, took the bull by the horns, which is syntactically similar to the first one. We will have to consider the noun that follows the verb, because we cannot replace it even with its plural form, needless to say, with other nouns. Okay. Now, when we classify multi-word expressions, we are going to be aware and to consider their part of speech. Yeah. So we are going to talk about several classes: verbal, nominal, modifier, functional or pronominal ones. Here we will focus only on verbal ones, but we have to be aware that other parts of speech are also possible. So we'll go for, well, I will present you this part because we will have, there are even some problematic cases with verbal multi-word expressions. When we are not sure if we should classify them among verbal or nominal ones. Think of non-finite verbal forms. Yeah. So we will first decide what part of speech they belong to, and this we are talking about candidates right now, right? So a candidate string of words, we have to decide what part of speech it belongs to. So what, and for this we look at its distribution. If its distribution in sentences resembles that of a determiner, conjunction, or adposition, then this is probably a functional multi-word expression, and will have to go to that respective decision tree, which we are not going to look at now. If it's not a determiner, then we have to check if it's maybe a modifier, so adjectival, adverbial. Otherwise, we'll have to check if it's a verbal one or a nominal one, and so on. Yeah. So depending on the distribution, we will have different decision trees, which we are going to consider for our analysis. Now, I presented previously sometimes of verbal multi-word expressions, but the categories that are used were used in Parsim and are used in Unidad now are these ones. Light verb constructions, which are further subdivided into light verb constructions pool, and this is the case of to give a lecture when the verb does not have any semantic contribution to the meaning of the whole expression. And we have light verb constructions cause, and here the verb has a semantic contribution, this causative meaning that it brings. Yeah, like to give someone a headache, you cause that person to have this problem, a headache. Then there are verbal idioms. We have some abbreviations for all these classes. The inherently reflexive verbs. Well, in English, these are rare cases. In Bulgarian, in Romanian, these are frequent cases. They are not easy to deal with, actually. You know that the reflexive, the accretive can have different meanings, and we have to distinguish between those different meanings and to choose only those occurrences where we have this inherently reflexive meaning. Then there is this category of verb particle constructions, which is further subclassified into verb particle constructions full and semi. In the first example, we have to do someone eats, or to do in. This is the verb. This is the expression. Someone is not part of it. To eat up, meaning eat all. Yeah. So it's semi non-compositional construction. It's not fully non-compositional, the latter example. And then we have a few cases in English, but more cases in Asian languages, for instance, of multi-verb construction, so combinations of verbs. Some of these categories are considered universals. Universals meaning that they occur in all those 26 languages that Eva presented, that are present in the corpus. And these are LVC and VID, so the first two. Others are semi-universals in the sense that they occur in many languages, but not in all. This is the case for the others. And what I haven't represented here, because for Bulgarian and for Romanian, we haven't coined them. Because we didn't have this need when annotating. There are language-specific classes. For Italian, for instance, they were defined. One actually was defined. And I think for Hebrew also, but I'm not sure this is the second language word. No, Swedish, I think, rather than Hebrew. For Italian, however, for sure, they do have one language-specific type. Is because they have those clitics that do attach to the nouns, and they need to offer a treatment for them. Okay, so after we have decided that a certain string of words is a potential multi-word expression and it has the distribution of a verb, yeah, we have to we have to test it, so to be sure that it is a multi-word expression, and if it is, to decide to what category it belongs. This is the decision tree, let's say the upper part of the decision tree for verbs, which is available at this link here. Be seen by participants online, because I think I shared the whole screen, but yes, okay. So it is available online, and here it is. So it's the same as I had in the picture on the slide, but here you also have links that do work. Okay, so we will start from the top of the decision tree and apply each test. So the first test, let's say, depending on the answer to this test, if it's yes or no, we will continue with what's beneath the respective answer. It's rather difficult to follow this. It's easier to have an example to work with. I have here this snippet of a sentence, let's say, the fate of the Republic rests on your shoulders. Yeah, so let's say this is a part of our corpus, and here we have this string rests on your shoulders, and we have a feeling that this could be a multi-word expression, and we have to be sure, so to test it. First of all, as I said, we have to decide if all words occurring here should be considered part of it. Yeah. So what about rests? I have the feeling it should be there, but your actually can be replaced by rests on my shoulders, on someone else's, on John's shoulders, and so on. As a native speaker, I know that your, so this determiner, can be replaced by other words. So this means that we shouldn't consider it as part of the expression, whereas the rests on shoulders, yeah, I think it's constant, it's always there. So I will test them together as one candidate multi-word expression. And I will go to the decision tree. Here the first test is has to do with the head of this. Remember, it's rests on shoulders. Yeah, this is our expression. And the question here is, do I have a unique verb as a functional syntactic head of this whole string? Well, the answer is yes. This is the verb who rests. Yeah, so I will have to continue here. Yes, so I will go here. The answer was yes. And I will have to apply this second test, which says, does this verb have exactly one lexicalized dependent D? Well, I have rests on shoulders. On shoulders is one dependent. I treat it as one syntactic unit. So yes, it is indeed only one lexicalized dependent. I will continue here. Yeah. So I will continue with test 3, lex such. Yeah. And this test asks us if there is a lexicalized subject in this expression. No, there isn't in this string that I'm considering. Yeah? So I will continue on this with this branch here. Structural test 4. What is the morphosyntactic category of D, the dependent? Yeah. Well, we had on shoulders. Yeah. What is this? Well, it's not a reflexive critic. I don't know if they can hear me or is in front. Yeah. It's not a particle, it's not a verb, it's an extended NP, noun phrase. Yeah, I have a preposition and the noun, that's an extended NP. So I will apply this LVC specific decision tree if I'm here. Yeah. Here we have links between the different decision trees, so I will follow this. And I have the LVC specific decision tree. Yeah, so from the general tree, I'm now in that tree that is specific to LVCs. So the first question here is the noun abstract in this string? Well, shoulders is not an abstract noun. It is a concrete one. So the answer here is no. In this case, this answer shows me that I do not have to do it light verb construction. So I will have to exit, which means go back in the general tree. If it works, it should work. Okay. So I was here, I applied the test, and the answer was no. Yeah, so I'm here now. I have to test if this is VID, so to apply the VID specific test. And the first one here is cran from cranberry. Remember, yeah, so those words that occur only in expressions, they never occur in the language alone, well, in other combinations, I mean. So, do I have to do with any cranberry word within this string? No. So the answer is no. I will have to, yeah, no. So I will continue with VID, but with the next text. Does the regular replacement of a component leads to unexpected meaning shift? Let's see. Let's try with something else instead of shoulders, let's say. Rests on back, arms. Do I still have this meaning to rest on someone's shoulders, so to be someone's duty to do something, responsibility? No. So if I have this unexpected meaning shift, this means, yeah, so the answer here, yeah, is yes. So this shows me that the string rests on shoulders is a VID. Yeah, so I have not only established that it is a multi-word expression or a verbal one, I have also classified it already. Yeah, so I know it's a VID type of verbal multi-word expression. So that's how we work with these decision trees. Well, that was the presentation, but it's easier to follow the decision tree instead of this example. Okay, that was this last slide. So remember, we always identify a candidate. We test its distribution. It's vital, yeah, to establish to what part of speech it might belong if it is a multi-word expression. And we go to that decision tree specific to that part of speech. We only work with verbs now, yeah? But we already have guidelines for other parts of speech. They are, well, they are on Google Drive, but available only to people who are involved in their development. We presented them in a previous event, so they do exist. Nelda can confirm. She participated in the other event. So what is challenging in this process is how to follow the, even from my experience at least, is how to go through the branches of these trees to make sure you never skip, you follow the right answer, so that you reach a certain decision, whatever that is. We are not dealing with multi-word expressions, or if we do, what type that is. So this would be what we are going to test on Wednesday morning. If you have questions regarding all three sessions, we are happy to answer them. If you want to sort of start now to check if you've understood this process, to make sure on Wednesday we can work as specialists on the corpus. Yes, please.
If you've gone through the tree exactly the way you should, what kinds of validations do you go through? Do you use third-party validation methods or some kind of other way to check whether somebody has gone through the tree?
From experience, we don't have any let's say automatic. We use something semi-automatic in the sense that when the process is over, when we finish annotation, there is a consistency check. And from this, the results of this consistency check, we understand if the annotators, have worked in the right way or in a similar way or not. If different annotators reach the same conclusion, so annotate a certain string in the same way, this consistency check does not tell you if they did it in the right way or not. Yeah, so we cannot be sure. Only reaching different conclusions would be a signal that something went wrong. We do not care if those different annotations come from the same annotator or from different annotators, because we are all humans, we all make mistakes, right? We get tired, we consider, we see things differently. So if I have the same string and I annotate it today, and tomorrow I have to do it again, I might reach a totally different conclusion, of course, or a different annotation, yeah? So it's not easy.
It's gonna work now.
Okay.
Using AI models to actually use external validation.
Well, we haven't tested this, but if Eva has something more to add to this.
I mean, we haven't we haven't found anything that is and we haven't tested anything, but we haven't found anything that is good for languages as Bulgarian and Romanian.
So, yeah,
It's gonna be very difficult to even find AI validation.
yeah, at the moment.
Yeah. Thank you. Anybody else with questions?
I wanted to ask if there is examples in Romania for multi-verbal compositions.
I think we have maybe two or something. I cannot tell them. I don't know them by heart, but I remember. But they were not annotated like this because the number is quite low. They are. We have a category other. So whenever you cannot find a category, you put everything in other. But others are very low in number in Romanian, and they are included here. Actually. Thanks for the question. It's a very good one because here in these guidelines, you can see at the top these buttons, let's say, I don't know how they are called. And these are the language codes. These are the 26, I hope, languages that are present in the corpus. And the guidelines should contain examples for all problems in these languages. So if now you can see that only the English button is active, but I can also activate, for instance, the Bulgarian language, and you noticed how the Bulgarian examples showed up. Yeah, I can, for instance, the Romanian ones. Yeah, so whenever you have a test with examples in English, you should also have examples in all these active languages here. Yeah, so you can easily find like this if they were presented, introduced here in the guidelines, and they are available for the respective language. It's you can easily understand them because you also have the glossing and the translation of the example, so it's easy to follow. And there is also a color code, let's say, used here. So whatever is in green is a multi-word expression. Whatever is red for the same language means it's not a multi-word expression. Yeah. So and also if you work with languages that are in the same family with the language you want to add here, you can check those close, let's say, languages to get inspired to see how others treated the same phenomenon. You may agree or disagree with arguments with that treatment, and this is important for the community as a whole. So guidelines can be adjusted all the time. Well, not every month, but we are versioning them, yeah.
Thank you.
You've heard it several times mentioned rest on shoulders as a potential multi-word expression. In fact, it only works as one if you say whose shoulders. So those rest on shoulders, rest on somebody's shoulders, where the somebody can vary. So maybe it's part of a broader question: how much more grammatical information do you include in the description of the expression, and what kinds what kinds can it be? Cover that.
Well, when you annotate the expression, you do not assign any linguistic information to it. Only if you create a lexicon, a dictionary of those, you can add such information. And as shown, the granularity, the different types of linguistic information that's available depends on various themes. For Bulgarian and Romanian, actually we try to cover more of all the different linguistic levels, with exceptions being formulated, and whatever goes by the rule is not included, although we covered less lexical material.
Yes, for this bilingual sort of resource that we extracted from WordNet. So for these cases, we try to provide as much information as possible, but they are a small amount, around 1,000. So.
Just It's a member of the team who developed this. I'm just.
It's worth considering.
Okay, so I'm just reminding my friends and colleagues that we use such slots that are variable that need to be filled in for the expression to be grammatical, as in Professor Drzezinski said it works against grammatical only if we specify whose shoulders. And it might not also be only be it is usually possessive pronoun, but it might be as adjective or even a PP, a prepositional phrase with some name or noun of the possessor. So some expressions are not take such slots that should be filled with grammatical expression, so as for the whole to be so that the whole should be grammatical in this way. Otherwise, it's not.
But within the Parsim annotation, there is no such information. I mean, you annotate only the lexicalized parts of the multiword expression.
And you?
So the link for Wednesday is also on the website. We'll be on the website, yeah.